I think we're just about ready to dive into it. I'm just gonna change a few things here. Okay. We are ready to go. All right, let's take a look. Right, so yesterday we left off at indexes because that just seemed way too much of a brain intensive part of the course for us to be tackling towards the end of the stream. So I left it for today, and yesterday we jumped into a little bit of the SQL game that we had. We had Keck, I think, suggest us that we do it. So we did that for a little bit, which was pretty interesting. It definitely showed to me that I'm not yet as proficient at SQL, even the basic SQL stuff that I thought I was. So it's a good thing. It's definitely a good thing. If we look at our roadmap, yeah, we're basically still tackling advanced PostgreSQL. Um, we're 26% done on our path thingy, but we're probably even less done. Right. Another thing that I wanted to say was that tomorrow there won't be a stream because I'm heading out to a conference. Well, not a conference. It's more like a employer market. I don't know how to translate that. Employer con for IT. So I'm gonna just check out what's up there. It's a long trip. It's on the other side of the country. So I'll be gone for the entire day. So unfortunately, we will not have a stream tomorrow. But fortunately, I've actually found a pretty interesting game that I might want to play on Sunday. So I'm looking forward to that. Anyway, let's jump into it. We're all refreshed. We're ready to go. Let's learn about indexes. Okay, so when working with databases on Codecademy, many lessons use relatively small databases. However, when working with databases in practice, they can become massive very quickly. Imagine, for instance, if you had a database with all the purchases, sales, employees, shipping data, and so on for a large retailer like Target, Walmart, or Amazon. Their databases must be massive. Without a good organization, large databases like that can become nothing more than a pile of unusable information. Designing your database thoughtfully with multiple tables, keys, and relationships can help. But what if you want to search through this massive amount of data and find specific records? That is where indexes comes into play. An index is an organization of the data in the table to help with the performance when searching and filtering records. A table can have 0, 1, or many indexes. There are some costs when using indexes, which we will cover later in this lesson. Let's start by learning how to see what indexes already exist on the table. Say you want to see what indexes exist in your products table. Well, then you would run the following query. So, PG indexes. Okay, PG indexes is a built-in view in PostgreSQL. Different database servers have different ways to see their indexes. During this lesson, we will be working mostly with the table customers created with randomly generated information. Depending on the exercise, the number of records might change to help with runtimes, but the structure of the table will remain unchanged. Okay, so we will learn what an index is and how they function, how to build an index, how to drop an index, and multi-column indexes that expand the power of your indexes, and also some of the benefits and burdens of indexes. All right, so query the database to get a sense of what the database will look like. This exercise is only a subset of the full data we will be using in other exercises to give you a sense of the type of information we will be working with without slowing down your experience. Slow me down, baby. Select all the rows from the customers table, take a look at the output, and notice the columns and data that are returned. As this will be the main table we will be working with, it will be beneficial to become familiar with. All right, so let's take a look. Customers. Okay, so we have roughly the basic stuff that you would expect in a customers table. We have ID, first name, last name, email, home phone, city, state name, and years old. I guess one thing to note is that it's something that my bootcamp lecturer brought up. It's probably a bad idea to store ages, years old like this, because unless you have some kind of function going in the background updating these numbers every single year, someone has to go into the database and update them every year. So, yeah. All right, so we have basically all the data that we need, except in the years old, I see some discrepancies where customer is 4 years old, 6 years old, 4 years old, 6 years old, 5 years old, 10 years old, and so on. And also 100 years old. It might be a person, but probably not. Do. What you have to do. Yes, I'm a fool. Falling in love with you. I love my music. It's such a nice thing to have, finally. Love we have would last for a million years. Okay. Enough with the singing. Let's actually do some work. So look up any indexes that already exist in the customers table. Greetings from Mexico. Hey Joe, welcome back. How's it going? How's the weather in Mexico? Because in Lithuania, it's goddamn dreary as hell. There's like a thick fog. It's raining. It's cold. It's windy. Well, no, it's not windy. Wouldn't make sense because there's fog. But all of the above are true. All right, so look up any indexes that already exist in customers table. We will need to scroll down towards the bottom of the output. You should see another query with the columns Shema name. Oh, I forgot how schema is pronounced. Schema name and table name. Those are indexes currently associated with the table. Pay particular attention to table name, index name, and index depth. Okay, let's take a look. E.g. indexes. I think that's about it. It's been good getting colder again. What is colder in Mexico? Like, what do you consider cold in Mexico? This is probably. Do you ever get below 0? Probably not as cold, but feeling it. That's why they have those new, well, not new, but they have those weather apps that give you like both what the like quote unquote official temperature is and also what the feeling is. Do. Wait, so it wasn't happy with this. e.g. indexes. Oh, where table name equals customers. Because now it's giving us all the indexes from all the tables. Where table name is equal to customers. Okay, so we got one. So the schema name is CC user. What? Table name customers. Index name, customers primary key. Never that cold? Never below 0? Okay. Yeah, the weather's been crazy lately. It's very inconsistent. Because just last weekend we had like plus 16, plus 17, and so on. It was very sunny. It was very nice. And then the week started and it was like 7, 8 with rain and wind. And now it's gonna pick up again on the weekend and then drop again into the 7s and 6s towards the next week. And people say climate change isn't real. Right, so create unique index definition. Customers primary key on ccuser.customers using B-tree. No idea what this is. Are you excited for the weekend? What are your plans? Hmm. Oh, it's just not happy that we deleted the customers thing. Okay. So pay particular attention to table name, index name, and index def. What do you think each of these represent? Well, table name is probably self-explanatory. It's table name. Index name is no idea. And then index def, probably a command of how you create an index of a particular schema, table, doctor's appointment, just a regular checkup, or being sick. Hopefully the former. What is the benefit of an index? So indexing allows you to organize your database structure in such a way that it makes finding specific records much faster. By default, it divides the possible matching records in half, then half, then half, and so on until the specific match you're searching for is found. This is known as binary tree. Oh, I see. Okay, let's consider an example to expand on this concept. Say you had a sales department where you ranked your clients from number 1 to 100 in order of loyalty. If you wanted to search the table for your most loyal client, you would have a loyalty score of 100. You would have to search every record. The highest loyalty score could be anywhere in the data set. If you create an index on loyalty score, you could now use the B-tree structure to speed up that search. The search would divide all results in half. So in this case, the first check would be if the record you are searching for is greater than or less than 50. Ah, I see. So it's like log O log of 2 speed. Well, not speed, like time complexity. Yeah. Log. Oh, log squared of n. Yeah. Where without it, you would have to check every record, so the read time would be n. In a small database, this is negligible, but as the datasets get larger, this becomes more significant. To highlight this, let's say you were searching 1 million records. Without an index on the column you were searching, you would need to look through all million records, assuming it's a non-unique column. With a B-tree index, in the worst case, you would have to search 20 comparisons. Follow up for the wife? Follow up usually means pregnancy? No? Okay, let's search for 15. This is without an index. Yeah, we have to search from the beginning towards the end. With the index, all we have to do is search 4 times, as opposed to 8. What if we do 35? Yeah, this is much faster. All right. Let's do some experimenting now to see the power of indexes in practice. We will cover the cost of indexes later on. For now, let's just focus on the positive aspects of them. Filtering data. As a note, this page will most likely run slower for you than any other exercise in this lesson. In order to see the benefits of an index, you need a large database. It may take some time to load the database and run your code. In future exercises, we will be working with smaller databases to not slow down your experience, but it's important for you to see the impact indexes can have, so please have patience with this exercise. Will do. To get insight into how PostgreSQL breaks down your statements into runnable parts, we can investigate the query plan by adding explain analyze before your query. Rather than returning the results of the query, it will return information about the query. Ah, okay. This would return the plan that the server will use to give you every row from every record from the customer's table. There's a good amount of information on what you can get from this, and a full understanding is outside the scope of this lesson. If you'd like to learn more, PostgreSQL official website has a full explanation of explain. For now, there are a few key things you should take note of. First thing is the planner. Will specifically tell you how it's searching. If you see sequence scan, this means that the system is scanning every record to find the specific records you're looking for. If you see index, in our examples, more specifically bitmap index scan, you know that the server is taking advantage of an index to improve the speed of your search. The other part to take note of is the planning time and execution time. Planning time is the amount of time the server spends deciding the best way to solve your query. Should it use an index or do a full scan of the tables, for instance? The execution time is the amount of time the actual query takes to run after the service decided on a plan of attack. You need to take both of these into consideration, and when examining your own indexes, those are crucial to understand how effective your indexes are. Okay. What? I don't remember adding this song to the playlist. Huh. All right, let's take a look. Let's start with a search on a column without an index. Select all columns from the rows of the customer table where first name is David. Okay. So before running your query, add explain analyze to the start of it. So, okay, explain, analyze, select customers table where first name is David from customers where first name equals David. All right, let's take a look. Ooh, it's slow. Not that slow, actually. Okay, so the query plan sequence scan on customer costs rows with actual time 0.018. Filter, first name David. Rows are removed by filter almost 100,000. Planning time is 0.284. Execution time is almost a second. Think. Okay. So the first name column doesn't have an index on it, but the last name column does. It's getting late here. Have early morning tomorrow. All good, man. Have a good evening. Sleep well. I will see you later. Thank you. Okay, so last name column has an index. Select all columns from the rows where last name equals Jones. Again, add explain analyze to start of the query. Did the index help? Let's take a look. So last name equals following me on YouTube now? Aw, man, thank you. I'm still deciding on how to best upload to YouTube because the backlog is getting crazy and I don't really have the time after stream to edit it out, especially this week when all my markers were broken, so the editing takes much longer. So I'll probably upload all the stuff from this week on Sunday. So, because there's, yeah. And I might make that a habit too, where I will upload weeks worth of Twitch content onto YouTube on weekends. But we'll see. Anyway, thank you for the follow on YouTube as well. So instead of David, we do Jones. Okay, so the query plan first was sequential scan. Here we have a bitmap heap scan. The first one took, the planning time was 0.26 milliseconds. Now it's 0.051. Damn, like 5 times faster. And execution time was also like 10 times faster. Okay. All right, let's take a look at how to build an index. I'm still not entirely sure, like, what does the index itself do? Does it like put your data or into an array essentially, some kind of data structure? I guess a table is a data structure, or does it like assign invisible index numbers to it? Okay, maybe they will explain it further on. So now that we talked about what an index is for, let's build one ourselves. In PostgreSQL, the create index keywords can be used to create an index on a column of a table. Okay, on a column. Say you wanted to create an index called customer username index on the customers table on the username column. This is how you would do that. So create index, name the index, specify the table and the row or the column. So keep in mind that indexes are great for searching, but like everything in life, nothing comes without a cost. In the case of indexes, it comes at the cost of increased runtime for any modification to the table data, impacting the username column. Another cost is the space that the index takes up. We'll go into more detail on these issues later. Okay, so we want to create an index. called customer city index on the customers table for the city column. Okay, so create index customers city IDX on customers city, right? And then we want to select all from EG indexes where table name is equal to customers. Okay, so now we can actually see that we have two indexes. Oh, okay. So it just specifies. Okay, so index name is fine. Is on the primary key. That's what I was confused about in the beginning. Is that primary key? What? And it's creating a unique index using binary tree on customer ID. Okay. So now we created a customer city index on ccuser.customers using a binary tree on city. Okay. Index filtering. When you're building indexes, keep in mind that they will be used for filtering your data quickly. Queries that filter data often use where and on clauses. If an index is created on the columns referenced in these clauses, the database server will examine the index to see if it will improve the speed of the query. Say you were asked to get the number of orders placed by each person with the last name of Smith or Jones. You could get that by running the following query. Select first name, last name, count order ID as number of orders from customers as C, inner join orders as O, or last name Smith Jones. You can do in with parenthesis with sort of tuples. Group by first name, last name. If the code block is hard to read, drag the boundary of this panel to make it wider. It's fine. In this script, the where clause is filtering the possible customers by last name. If there's an index on customer last name, the database server will use this to quickly find the specific customer to examine. If there is an index on customer last name, the database will use this to quickly find specific customers to examine. Okay. Another filter in this query is the inner join between orders and customers of the customer ID. If there are indexes on these columns, one for orders.customer ID and another for customers customer ID, they could also be searched faster using the respective indexes. Filtering isn't perfect, and when you add an and or ors, it can complicate the filtering. Often real-world queries get very complicated, joining multiple tables, each with an on clause which may or may not use an index and multiple possible clauses in the where. The server needs to process all of these and identify the best way to filter the information. Sometimes, even if you have an index for the specific situation, the server might not use it. Testing is crucial for the specific queries you're working with. However, this in-depth analysis is outside the scope of this lesson, but it is important that you're aware of it. Okay, so even if we create an index, the server decides what it's going to use. And if your specific query is faster without using an index, then it's just not going to use an index. I wonder if there's a way to force it to use an index. Okay, so in the example above, the where clause is filtering the customers table based on last name and last name it is interested in finding. Let's add an index to improve future searches on this table and column. Don't forget the naming convention for indexes. Table name, column ID, IDX. All right. If you would like to confirm your index was successfully built, you can check the table to see. Recall this is done by running blah, 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 blah. Okay, so create index. It's create index, right? 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 I'm not crazy? Let's go back. Let's have that lesson on call. Yes, it's create index. Create index, we are trying to do based on the last name. So customers L name IDX. Let's do that. On customers. Yeah, on customers last name. And so this should create an index, and we can take a look. We can actually query something from the index. So let's try to do select, let's say everything from customers where last name, like something something and an. Right, before the select, what was the thing? Explain, analyze. Explain, analyze. Explain, analyze. All right, so we can do this before and after. Now let's take a look. So rows removed by filter 99. Planning time 7 milliseconds. Execution time is 0.05 milliseconds. With the index applied, its planning time is 1.8 and the execution time is 0.029, so 0.03. Okay. So, yeah, as they said, for smaller databases, it's probably not very effective. But still, we shaved off like half of the time on the execution. So that's pretty good. And also, let's take a look at index table. So yes, the index was created using binary tree on last name. I also wonder, can you specify which algorithm to use? Or can you even like build your own algorithm? All right, what are you unhappy about? Table customers column. Yes, I did. Probably unhappy that I did all this. Yeah. All right, let's delete all of that. What? What's your problem, buddy? Customer's last name index. Wow. So picky. Codecademy. So picky. Okay. So what if you have two or more columns that are always associated together? You can combine them to make a more appropriate index. Or can you combine them? Much like constraints, you can combine multiple columns together as a single index. When using multi-column indexes, the search structure will be based on the value found in all of the columns. For example, an index on first and last name might be a good idea if it is common to search by both together in your situation. Consider a table where the last names Smith and Johnson appear many times. Having another filter for the first name can help you find someone named Sarah Smith much faster. The index is built in the specific order listed at creation. So last name, first name is different from first name and last name. Ah, okay. Keep in mind, keep this in mind when you're building your indexes, as the order will impact the efficiency of your searches. So you would probably want to test it out, like which way works best. I mean, it sounds very situational, right? It's not something that you'd probably think about when creating databases because you don't really know how people will work with the database and so on and so forth. It's only after a while, once you have like some kind of pattern set up and that you see that people are interact how people are interacting with the table or with the tables or with the database, then you can start implementing indexes to improve query times, performance, and so on. Is my assumption. I don't know. Okay, so say you want to find David, Rachel, and Margaret from the first name column with the last name of Smith. If there is an index last name, first name, the server would find everyone within the last name Smith. Then in that much smaller group, find the first names you are searching for. If the index is first name and last name, the server would go to search for the first name records you are interested in and then search for the last name Smith within each one. In general, there isn't a right or wrong order. It's about what is appropriate for your setup and what you expect the index to be used for. If there's a good use for it, you could create both indexes as well. If you are if both are present when you run your script, the database server will determine which index to use based on your query. But remember, indexes take up space, so you shouldn't always create every index you can think of. Why not? What if I like indexes? What if I want to do it? Okay, so for a multi-column index, you only need to list out each column in the order you wish them to be used. So if we wanted to create an index called customer last name, first name ITX for the customer's table for the combination of last name and first name, it would be written like this. So the syntax is identical except for the columns where we include not one but two. And we mind the order in which we include them. Okay. In theory, you could list as many columns as your table has. We will discuss later why, in most cases, this would not be a good use of an index. As a note, you might hear a multi-column index referred to by other names as well, such as composite or compound. Okay. So run an explain, analyze, select for all columns where last name is Jones and first name is David. Remember, PostgreSQL is case sensitive. Know that we haven't created an index yet. Let's see how long this query takes without an index. Sure. Explain, analyze. Thor is being sleepy. Explain, analyze, select all from customers where last name equals Jones and first name equals David. All right, we have 10,000 rows. Planning time was 0.2 milliseconds, and the execution time was 13 milliseconds. Okay, let's create a multi-column index. Create index customers L name F name IDX on customers, and we do last name and first name. I hate that they wanted me to call it a specific thing. Okay, let's see. And let's run explain analyze again. Oh, wow. We actually shaved off like a lot of time. Like always keeping an eye out on these like loops and stuff because I don't know what they mean. Okay. In PostgreSQL, the drop index command can be used to drop an existing index. We will soon go over why you might want to drop an index you have built. But for now, let's learn the syntax to drop an index. Say we want to drop the index customer city IDX. Know that we pair the drop statement with the optional if exists to protect from execution errors. We will get into some situations where you might want to drop an index you have already created in the following exercises. For now, though, you need to know how to drop them when appropriate. Okay, so drop. All right, I need to sort through my playlist to make it a bit more PG-13. A lot of Hollywood Undead in there. Wait, let's do this. Let's turn off shuffle. Wait, what the hell? I'm fairly certain this playlist kind of started differently before. Let's try to reload. Wait. Oh, whatever. Let's put it back where it belongs. Not taking up the whole screen. Okay. So drop index if exists. So we need to examine the current indexes. Never mind. Select all from EG indexes where table name equals customers. Well, mistake with the where. So we have customers p key and we have customers last name index. So we drop that. Drop index if exists. And we just type in the thing. Okay, customers last name index. What? IDX, not index. IDX. And now let's take a look at the same table. And it's gone. Congratulations. So now we get to the $1 million question. Why not index every column? You might be asking yourself, if indexes are so wonderful and help speed up searches, why not create an index on every column? The short answer is that everything has a cost. Indexes speed up searching and filtering. However, they slow down insert, update, and delete statements. Okay. So let's look at each in turn. The easiest to understand is how an index works with an insert statement. When you insert a record into a non-indexed table, the database server simply adds the records onto the end of the table. However, when we add a record to a table that has an index, the index itself must be modified by the server as well. Recall that at its core, an index is an organization of the data in the table. When new data is added, the index will be reshaped to fit that new data into its organization. This means that when you write a single statement to modify the records, the server will have to modify every index that would be impacted by this change. If you're adding a large amount of data to an existing table, it may be better to drop the index, add the data, and then recreate the index, rather than having to update the index on each insertion. Huh, interesting. Keep in mind that these drawbacks are for each index you have on your table. If you have multiple indexes on a single table and you insert a record, you will need to update each index associated with the table. This can make indexes very costly. Updates and deletes have similar drawbacks. When deleting a record that is associated with an index, it must be faster. It might be faster to find that record by leveraging the index's ability to search. However, once the record is found, removing or editing it will result in the same issue as inserting a new record. The index itself will need to be redone. Note that if you are updating a non-indexed column, that update will be unaffected by the index. So if you're updating a non-indexed column while filtering by one with an index, an update statement can actually be faster with an index. The key to indexes is to plan on when an index will help you and stay away from when they will get in the way. Yep. Essentially, I guess if you have a database that people are not really adding, updating, or doing like changing it too much, you probably could get away with just slapping an index on every single column and being done with it. Okay, so for this exercise, we are going to do things a little differently. Given how time consuming it would be to have you manually create enough records to feel the impact of indexes, when inserting, we are going to take a shortcut and give you the script already set up to run. Okay. To start with, you will have to see what we are getting. What? Oh my god, I had a mini stroke there. To start to start with, you will see that we are getting the current time. Then doing a bulk insert load from a file, which is much faster than loading all the lines in the file one at a time. Then getting the time after the load has finished. Take note of how long it takes for this insert to complete. Note, whoever set up this table you are inserting into created a very bad index on the table covering all the columns in the table. This was done to simulate the possible impact of complicated and or multiple indexes on a table when doing an insert. Remember that if you were doing this on a table that already had records and was doing it by individual lines instead of a bulk inserter, the impact would be larger. For now, simply press run. Take note of the start and end timestamps. That's a mouthful of reading. So it took us a second. essentially, a little bit over a second, which is, I guess, in programming terms, it's insane. But now let's get rid of that bad index and see how long it takes us to do that bulk insert again. In the workspace, on the first line above the code that's already in there, add this. Drop index if exists. Customer bad IDX. Run the script again and compare the time. Nope. Index customer bad IDX does not exist. Oh, customers. Sorry, my bad. Okay, so this time it took 0.3 seconds. Okay. So something like 4 times faster. I suppose. I mean, it's hard to really put this into perspective because, like, okay, 100,000 rows, that seems a lot, right? But if you're not working for one of those mega giants, you know, uh, Amazon, Facebook, whatever, how, like, what's the average length? What's the average size of a database in like a medium sized company? Like overall, I don't know. So it's hard to put that into perspective and to really appreciate whether indexes are actually this useful or only useful on gigantic mammoth mega databases. Yeah, we should call them mega bases now from now on. Okay, so continuing on the topic of why not index every column, another place where an index falls short of perfection is that indexes take up space. The index data structures can sometimes take up as much space as the table itself. Oh, okay. If you have not worked with large databases before, you might be thinking yourself, who cares? Storage space is cheap nowadays. Yeah, I mean, it is. However, databases of decent size can easily get into the gigabyte size range quickly. This means every time your database administrator does a backup, does a full backup, all of that information, indexes included, are copied. Also consider copying the database to a different environment for testing and development, or running your database on different servers and at different physical locations. All of that data goes across the internet, and some companies pay for the data usage across networks on their plans. If you then bloat your database size by creating an index on every column, you have compounded all these issues and expenses. See, given the speed advantages of indexes can provide when used properly, you should not ignore them. But keep in mind this balance. If you want to create the size, if you want to examine the size of a table of products, you would run pg size pretty. Okay. So select. There's a lot of queries that I that are just like, what is going on? PG size size pretty. PG total relation size, and then customers. 13 megabytes for 100,000 rows. That's fine, right? All right, let's create an index. And let's take a look at how big the size will be then. Customers last name IDX. Customers last name. Okay, and let's take a look at the file size after that. 15 megabytes. It's just 2 megabyte increase. Oh, I have to. I have to. Average size of databases. I don't know. Warehousing projects. This would be a very generic question. It all depends upon the type of data being stored. A project may receive huge data on a daily basis, but the requirement may be to store it only for a week or so. In this case, the size can be somewhere in the range of 10 to 20 times of the data received per day without any other requirement. In other cases, the daily transaction size may be small, but the project would not have any housekeeping requirement. Predicting the size for such scenario would depend on a huge number of factors: scalability, performance expected, etc. One example: warehouse size is 5 terabytes. Expected storage of around 100 files of different transactions with size ranging from 10 kilobytes to 1 gigabyte, which is very rare. Mode of file size is 20 megabytes. Warehouse is a write-only system. Data cannot be overwritten, so in case of failure, the entire file is rewritten. Also, there are other operations available which may cause rewriting some data multiple times. Housekeeping is done every 7 days. This didn't really answer my question. I implemented EW for a consulting organization that had about 1.2 million transactions every 4 hours. It was several terabytes. Hmm. There really is no typical size, as it varies based on how many products you have, how many variants, attributes, customers, blog entries, forum posts, etc., etc. We have an installation with about 200 products and the blog, and currently it's consuming about 25 megabytes of space. Yeah, it's I mean 200 products. Okay, let's put that into perspective, right? How many products does Amazon have? Okay, so that's 353 million. Wait, total number of products, including those from third-party sellers, in excess of 353 million. Okay, now I'm gonna be challenged on my math, but so calculator. 353,000,000 divided by 200. We get 1.765 million. So we take that number and we multiply that by 25 megabytes. We get 44 million megabytes, which we divide. Yeah, we divide that by. Wait, what's the size of? Oh my god, I should know this. Size of megabyte. What? 1,000? Okay, we're doing rough calculations. Let's do 1,000. So divided by 1,000, that's 44,000 gigabytes, right? And 1,000 gigabytes is 1 terabyte. So that's 44 terabytes. Wait, what? Oh, yeah, okay, 44 terabytes. and 0.44 petabyte. I guess 44 terabytes. I mean, for Amazon, that's that's peanuts, no? They probably okay. Okay. Amazon database size. Two largest databases combine for more than 42 terabytes of data. And that's only the beginning of things. If Amazon published the total number of databases they maintain and volume of data each database contained, the amount we know Amazon houses would be would increase substantially. So Amazon does have the largest database apparently. After less than 2 years of operation, YouTube has amassed the largest video library and subsequently one of the largest databases in the world. YouTube currently boasts of user base that watches more than. This is an old article, isn't it? Yeah, it's 215. Holy crap. Okay, now that I think about it, there's no way that Amazon has the largest database. YouTube, it's got to be it, right? Because they store videos. YouTube database size. At least 1 exabyte, which is 1,000,000 terabytes. Oh my god. Every day, 720,000 hours worth of content is uploaded to YouTube. Oh my god. Wait, they have at least 1 exabyte of storage. How much of that storage is in use? That's a whole nother thing. Hmm. Okay. Let's go back to our 12 megabyte database here. All right, we're moving on. Index filtering. When you are building indexes, keep in mind that they will be used for filtering your data quickly. Queries that filter data often use where and on clauses. If an index is created on the columns referenced in these clauses, the database server will examine the index to see if it will improve the speed of the query. Say you were asked to get the number of orders. Oh, wait, no, never mind. That's the wrong thing. We were here. So, when should I add an index? You may be asking, when should I add an index to my database? Simple answer is when the benefits of searching outweigh the burdens of storage size and insert, update, delete speed. One thing to consider is whether searching will occur often enough to make the advantage worth the time and effort. In the real world, this often becomes a gray area and one that you might have to go back to after trying for a while. You will want to look at what a table is used for and by who. Yeah, so like we said, you have to know your users and how often they're using it and how they're using it. As a very rough rule of thumb, think carefully about any index on that table that gets regular insert, update, and delete. In contrast, a table that is fairly stable but is searched regularly might be a good candidate for an index. Well, yeah. There are some other conditions that can impact your search times you should be aware of when using an index. The higher the percentage of a table you are returning to, the higher the percentage of a table you are returning, the less useful an index becomes. What do you mean returning? if we're only searching for one record in a million, an index could be incredibly useful. Ah, if we're searching for 900,000 out of the same million, the advantage of an index becomes useless. At higher percentages, the query planner might completely ignore your index and do a full table scan, making your index only a burden on the system. I see. So that the scope that, or like the size of your search also matters. So even if you have a lot of searches, but all those searches are for like single cell values, then you could still potentially add an index. Okay. So along the same line, if you're combining filtering conditions, be aware of what you will be searching on. And statements are normally fine, and the query planner will try to use an index field before non-index fields to cut down on the total number of records needed to be searched. Or, on the other hand, can be very dangerous. Even if you have a single non-indexed condition, if it is an or, the system will still have to check every record in your table, making your index useless. See. For instance, if you have the following index on the customer table, and you ran the two following queries. So we have one with an and one with an or. The first would run in approximately 1 millisecond. The second would take 33 in the local version of customers table with 100,000 records. Because the first one uses the index, it can jump right to just the records within the last name equals Jones. However, in the second with the or, the index is useless since every record has to be searched anyway for any record with first name David. The index is ignored and the system looks at every record once, checking both conditions. Okay. Let's take a break. All right. I knew I forgot something. When I went on a break, I forgot the timer. But then I remembered the timer. And then I had to estimate how much time I had been away from for how long. Sentences, man. They're hard. Okay, let's get back to it. So, we have two situations. One might benefit from an index. Pick the correct one and build the index for it. Feel free to look at the hint to see an explanation of why one is correct and the other one is not. So, the first one is your boss asks you to run a one-time query to find out why your website slowed down for users so much last night. Your boss asks you to create an index on the logons table on the logon time to find out how quickly many users logged in last night. Should be called logons logon time IDX. And then we have your shipping department needs a list each night of the orders for the day organized by the city for each customer's in order. Okay. So I'm assuming it's the first one because it's just a one-time search. So create index logons logon time IDX on logons logon time. No. What? It's not the one? Okay. Let's take a look. Customers city IDX on customers city. Okay, so why? This would be not a good place to build an index. The first clue is it is for a one-time query, which means that the cost of building the index would probably be offset by its benefit of searching. The next the next is this table is a common one for inserts, as every time a user logs in, a new record will be created. The last thing you want to do is slow down customer experience if you can avoid it. Okay, makes sense. I got my logic backwards. So this might be a good use for index. The main key is that it is a frequent search, meaning you will get the chance to gain benefit out of the cost of having an index. It would need to be monitored to make sure it didn't slow down the customer experience during ordering. You're better off making your internal shipping department wait instead of your customers. Right. Yeah. Okay. Makes sense. Makes sense. This time, build the correct multi-column index on the customers table. You find that searches for customers by last name are running slow. You know you need to find their first name, last name, and email address. Create an index that might help with this. Not all possible combinations are listed, and there are other valid ones. Please select one from below list to help with the checking for accuracy. So we obviously probably want to search by email first because that's the least repeating thing, least repeating column, probably. So once we narrow that down, we could then do last name and then first name. But in the con combine no, what's the word? Con confines. Within the confines of this exercise, it's the last one. So create index customers last name email. No, 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 no. Email address. Already started your $1 billion startup. Hey, happy. No, not yet. Not yet. We're on a database building section of it. We got to build a killer database first, then we're doing the startup. How you doing, Happy? How's your Friday going? How was your week? I don't think I've seen you the whole week. Maybe in the beginning of the week? Customer email address, first name, last name, IDX on customers, email address, first name, and last name. That's a lengthy query. No. Last name, email address, first name. It was a stressful week. One of my projects decided to explode while testing. Ooh. Tell me more. Now I'm curious. How does a project explode? Unless you don't want to talk about it, then that's fine too. Okay, how come it's the last name first then? Things that work doesn't work anymore? I can relate. Beginning of the week was very weird for me as well in terms of streaming. Because I logged in or I got onto OBS and nothing worked. Of course, it's not comparable to Project exploding, but maybe it's a typical, but it works on my development machine. Maybe. So did it get fixed or is that still a work in progress? Because the main search filter is last name. You want that to be the first thing the index is built upon. Well, you didn't show me the query, so how am I supposed to? Okay, never mind. For customers by last name. Never mind. Never mind. Currently working on it. Could be fixed faster, but I used the time to clean some things up. Well, at least it's getting better. You know, things break. No biggie. That's why they hire people. Because if you build something and it never breaks, then we'd probably be out of job pretty fast. Okay, so we're done with indexing. I assume a quiz is coming. It's the first project I started when I joined the company 3 years ago, and I had no idea what I was doing. And you can see that while looking at the source code. It does happen. I when I visit my some of my older projects, even though I haven't been learning programming for that long, it's only like half a year or something, I already can see the difference in both the quality code and the spaghetti stuff that I've written before. Drop index name. In PostgreSQL, a query plan can be shown for scripts. A query plan can be shown for scripts. This can be used to see the runtime of a query and how the query is processed. What do you add to the start of your query to get the actual execution plan that was used? Is it explain analyze or I think it's explain analyze. Yep. Indexes are used to increase the speed of filtering data. When does PostgreSQL use these indexes? So when we have filtering with where. Indexes are often used in where clauses and when two tables are joined together using on clauses. Yeah. Already miss PostgreSQL and MySQL? Well, stick around. You'll be able to relive PostgreSQL. Even though we're using Microsoft SQL at work and I really hate it, actually, I'll have to learn Microsoft SQL. I'm learning Postgres because it's in the course and I want to finish certain topics of the course. And this was part of the database unit. So I'm just learning PostgreSQL for that. But essentially, what I need for my job that I'm hoping to get is Microsoft SQL. That's what they're using. So we'll be learning that as well. Enjoy as long as you can. I mean, how bad can it be? SQL is SQL. It's not like learning an entirely different, I don't know. It's not like going from a relational. it's not. It's not like going from a relational database to like non-relational database. Probably where you probably need to learn an entirely different query language. Basically is, but there are some things you'll wonder about. There already is in PostgreSQL too. In SQL in general, there are things I wonder about. But it's a query language. It's ah, just some practice. Put in some practice, you'll be fine. Or I will be fine if I put in some practice. Okay, to see the size of the database table, you can run the following script. Select, I think it was PG size pretty column name here and relation size. For example, there is no on update. You have to implement a complete trigger for it. There's also no Boolean data type. You have to use a bit which is translated into a tiny int. Oh. Yeah, that that definitely makes me wonder. It's slow? Okay. How slow are we talking? Oh, crap. Indexes are used to increase the speed by filtering data. This one, drop index, index name. How do you find the current indexes on the table? PG indexes, table name equals table name. You probably know ID, int, unsigned, not null, auto increment, primary key, right? I know everything besides unsigned. And instead of auto increment, I think it's serial in PostgreSQL. Unsigned. I think it's unsigned, is what you meant, right? Size of the database table. E.g. pretty. Relational size. Table name. Unsigned means there are only positive numbers. Oh, okay. Okay, so in Microsoft SQL, it is ID int identity 1 1. The hell's identity? These small differences drive me crazy. So, okay, int is still there. Not null is still there. Auto increment. So I assume identity replaces auto increment and unsigned. Yeah. And the numbers in parentheses just tell it to how to increment, I'm guessing. It just forgot unsigned. Okay. Well, it's not too bad. I'm sure it'll take some time to get used to the differences, but I'm hopeful that as I use it, I will learn. You know, practice, practice, practice. Multi-column indexes allow for more than one column to be used in combination as an index on a table. Fill in the syntax to do this for 2 columns. Note that you can join as many columns as there are in the table, but in this example, we're only joining 2. You worked with PostgreSQL and MySQL for years. You'll hate Microsoft SQL. I haven't worked on them for years. So, plus for me, minus for you. Didn't even talk about things like importing, exporting databases, creating views, etc. I don't even know how to create a view in PostgreSQL yet. So yeah. Okay, create index index name on blah, 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 table name column 1, column 2. Well, I can imagine it being frustrating. It's like you learn it one way, you do it for years, and then you have to do it the other way. But the fact that you've been doing it for years one way is also a big benefit. It's better than not having done it at all. You need a Discord server where I can complain all day. Actually, you know what? I'm not a big fan of Discord because I don't really use it for anything. Where's my thing? Because I don't really use it for anything, but now that you mention it, we can add it to things to do. Wait. Things to do. Create a Discord. Sure. Discord, please. Server. Okay. I need a suggestion box. That's actually a thing that I'm gonna probably implement once I hit affiliate. Is like a suggestion box using channel points. People can just leave suggestions, and maybe we'll do it on the week. Actually, I just closed it, but I need to write it down as well so I don't forget. Bum, 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 bum. Implement suggestion box using channel points. And then also here we can have a suggestion box reading or checking. Sure. Okay. In the meantime, you can complain here. It's fine. Just go on a an hour long rant about SQL. I'll take it. So one of the downsides of creating an index in PostgreSQL is that the indexes slow down data entry or modification. Whenever a new row is added that contains a column with an index, that index is modified as well. True or false? If you're adding a large amount of data to an existing table, it may be better to drop the index, add the data, and then recreate the index rather than having to update the index on each insertion. It's true. What is one of the downsides of creating an index in PostgreSQL? Adding an index will create a new table. No. An index is a new structure separate from your existing tables that will take up space in your database. Well, yes. Adding an index will create a new column in your table, which takes up. Yeah. In a relational database like PostgreSQL, indexes are used to improve the speed of searching and filtering. Sure. However, these improvements come at a cost. One of these costs is the speed of other actions in the database. What are some of these costs associated with adding an index to the table? So, insert, update, and delete can take longer to complete. That's an unintentional rhyme. Insert, update, and delete can take longer to complete. In PostgreSQL, the create index keyword can be used to create an index on a column of a table. The specific syntax will look like create index, index name on table, and column name. What are your plans for the weekend, Happy? I hope it's not fixing work stuff. In PostgreSQL, a query plan can be shown for scripts. This can be used to see the runtime of query. Oh, it's explain, analyze. Yep. I follow you. Okay, so project time. Running an online bookstore and need to keep track of what books we offer. We'll be working with a database of 3 tables. There's a new event in our local animal shelter, but that's all we planned for the weekend. Oh, that's cool. What kind of event is it? Uh, I'm actually going tomorrow. I'm actually going to another city for a employer sort of employer market, I guess. Employer con. It's basically a place where all the employers come and they just here we are. This is what we do. And it's like tech related. So I'll be visiting that for the entire day. So tomorrow's stream is not gonna happen, unfortunately. It's like get to know us. Oh, okay. Well, this is still cool. Meeting lots of dogs. Do you have a dog yourself? Or an animal of some sort? So yeah, that's the thing. Also gonna meet a couple of people from my boot camp because they live in that specific city and it's like 300 kilometers away. So I haven't really met them in person yet. Oh yeah, you told me you have 3 rats. I forgot about that. Sorry. Right. Those hilarious names, which I already forgot as well. But to be fair to me, they're not the easiest names to remember. So that's a stone in your garden. This project will most likely run slower for you than most other projects in Codecademy. In order to see the benefits of an index, you need a large database. We try to make the database as small as possible, but still large enough to get a benefit of creating good indexes. Okay. So before we start having fun with the database, familiarize yourself with what we are starting with. Look at the first 10 rows in each table: customers, orders, and books. Or no. Um, Luckily, you don't have to remember the names. Customers, orders, and books. You never know. One day you might be in a bad mood. Just come into the stream and be like, "What are my rats' names? Tell me or I'll unfollow," and never come back. So, you know. Okay, so we have them 3 tables. We have customers, we have orders. No, this is customers, this is orders. And we have books. Now I know what I have to do next week. Uh, Quickly remind me of your rats' names. I'm gonna jot them down here somewhere and practice them in my sleep or something. No, I'll have to go back to the VOD and take a look at the chat. Okay, so pretty standard stuff. Before you make any changes to a database and its tables, you should know what you're working with. Examine the indexes that already exist on the 3 tables. Can you think of any right now that might be useful to add? Okay, let's check the indexes. Select all from, what was it, PG indexes? Yes, where table name, or is it single? Yeah, it's single. Table name equals customers. Actually, in customers, orders, orders, and books. That should work, right? Yep. Okay, so we have basically just indexes on the IDs. Book ID, order ID, customer ID. Yes. Okay. While looking over the history of the queries you have been running for the marketing and shipping departments over the last month, you notice that you're looking at the foreign keys in the orders table, customer ID and book ID, often enough that you think it might be a good idea to build an index on each of these columns. You do note that although they do sometimes ask for information on who places an order and the specific book they ordered, most of the time they ask for only one of these at a time. Add the indexes to help speed this process. Can you think of any dangers of this? Okay, so we want to look at orders and we want to try and add indexes on customer ID and book ID. You do note that although they do sometimes ask for information on who placed an order, and the specific book, most of the time they ask for one of these at a time. So I'm thinking, is it worth placing a sort of a compound index on both of these, or just two indexes on each? Probably two indexes on each. Or wait, when placing, is there such a thing as compound index? No, there is. Because it then would look at this and that. Okay, let's just put two indexes on both of these columns. Create index, and we will do one for customer ID. In orders, customer ID. And then another one, which would be book ID, IDX. In orders, book ID. So that should have placed two indexes on the orders table. Ooh. What? Is it not in? Oh, it's on. Okay. Okay, so now we have two more. So they got placed. So we are about to create a multi-column index, but before we do this, let's get some information prepared to make sure we're ready to analyze if it was a good idea or a bad idea to create. Well, what we could do is explain, analyze, select all from orders, where let's say, so we're putting on customer ID. Okay, so let's do where customer ID is, say, greater than 10, and the and condition shouldn't impact it too much, and customer ID is less than 100. And let's limit that to 10. So we can do this before and after. Also, we can do the same for books, book ID. Before and after. Plain analyze, check query, searching original language title, and sales in millions from the books table that have an original language of French. No, I won't do that. I will do this. Okay, so when querying customer ID before the index, we had 0.1, 0.8 milliseconds execution time. After it, it's 0.068, I think. There's a bit more information the second time around. And then after querying the book's ID, or so before the index, it was, wait, what? Before the index, it was 0.016. After index, it was, whoa, that was much slower. How come? Okay, what if we do a joint index or a multi-column index? Let's comment all of this out. Let's create an index. Customer ID, book ID. Customer ID, book ID. So let's have this index. And then we want to query. Now the question is, to see the impact, do we query just one column or both of them? Well, I guess we can do both. So we can do from orders where customer ID is greater than 10 and book ID is less than 100. Sure. Oh, we forgot to do it beforehand. Okay, so it's actually largely the same. Pretty much. Execution time is exactly the same. What if we switch it up? Let's copy this entire thing, paste it here, and instead of this, we will switch them places. And this should be fine. Let's take a look. Okay, so once again, not that much of a difference in execution speed. And also not that much of a difference, but it's much faster than just individual queries or individual indexes. So our fastest one that we did was on customer ID. So if we just delete this and uncomment this, so this one we had 0.63, whereas in this one, even before applying an index, was way faster, actually. Maybe there's no point in adding indexes here. Well, okay, this before and after it. That's good. So we definitely benefit from an index on customer ID if we're querying customer ID often. Or filtering by it, I mean. But otherwise, we're actually losing. We run it again. Yeah, pretty much consistent results. 17, 0.023. Okay, so we can basically delete all of this and just leave the index on customer ID. So we are about to create a multi-column index. Make sure ready to analyze if it was good or bad index to create. It's a bad index. Use explain to analyze to check the runtime of query searching for the original language title and sales in millions from the books table that have an original language of French. Okay. Explain analyze, select original language title and sales in millions from books where no language is equal to French. 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 We got nothing. Books, original language. Huh? Are there any books in French? Oh, there are. Oh, we're not actually querying. That's okay. I forgot how explain analyze works. We're just showing this information. Okay, so remember, runtime isn't the only impact that indexes have. They also impact the size of your table. So let's get the size of books table. Okay. Nope, not the thing. Huh? Relation? Oh, table name. Okay, 56 kilobytes. Now let's take a look at the situation you were preparing for. Your translation team needs a list of languages of the language they are written in. List of the language they're written in. Book titles and the number of copies sold to see if it is worth the time and money in translating these books. Create an index to help speed up searching for this information. So I guess we create a multi-column index. Book titles needs a language. Language. Title. Copies. IDX. On books. So we're doing language, language, language. Original Language. How come it's so hard to write language? Language. Title. And copies sold. So sales in millions. Love we have would last for 1,000,000 years. Now that you have your index, let's repeat the process in tasks 1 and 2. Compare the runtime and size of the index in place. To make a true assessment, you would also have to look at other impacts of such an index, such as the impact on insert, update, and delete statements on the table. With just the size and runtime of this query, do you think this is a useful index? Okay, let's take a look. Huh? This quota exceeded. Okay, let's comment these out. Maybe that's the problem here. What? It's not running at all anymore. I think I broke Codecademy. Yeah, I think I broke Codecademy. My god. Okay, let's reset the workspace. Come on, Codecademy, you can do it. You can do the thing. Nope, it's just it's just broken. Now it's lost connection too. Did I just hack or like DDoS Codecademy by accident? Seems like it. All right, let's do a hard reload. Nope, doesn't help. Okay, we broke it. It's broken now. Okay, well, it's about time for a break. So let's take a break, and hopefully, in that time, Codecademy comes back to its senses and starts cooperating with us again. Yeah. In the meantime, go grab a coffee, stretch your legs. I'll be back. Okay, we're back. And unfortunately, Codecademy is still broken. For a moment there, I forgot we broke it. Okay, what if we go back to the syllabus and just go to the project like this? Okay, it's lost connection. We broke it, and they're not letting us back in. And here I was saying that there were no technical difficulties today. I just jinxed myself. Okay, what if we restart the browser? Will they even let us into the website? Yes. Okay. Let's resume. Nope, still lost connection. How do we what? Um Tools, auto close brackets and quotes. Code autocomplete. Um we broke it. We broke it. It's broken now. But it's this specific exercise because I think if we go to further ones, should be fine. Yeah, this one's fine. So, okay, we're just not doing that then? Okay, we'll update this. We'll take a look at it later. I guess we just move on then. Okay, so what else is there to learn about indexes? Now that you have a good base of understanding of indexes, let us dive deeper to explore in more detail how they work and how you can use them to improve the systems you work on. In the previous lesson, we learned what an index is and how they function, how to build one, how to drop an index, multi-column indexes used to expand the power of our indexes, some of the benefits and burdens of indexes. In this lesson, we will learn how to build a partial index, how to improve the speed of ordering data, and the relationships between primary keys and unique indexes, and unique constraints and unique indexes. How clustered and non clustered indexes work, index only scans, combining indexes versus multi column indexes, and indexes based on expressions. Like in the previous lesson, we will at times be working with larger databases, so some of our execution times on the site might be longer than you have experienced. Please be patient. I hope we don't break it again, is all I'm gonna say. Okay, I got scared that my mic was muted, but it's not. Okay, so query the database to get a sense of what the database will look like. This exercise is only a subset of the full data, blah, 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 blah. So select all from customers. All right, let's take a look at the PG indexes already in there. We have one on the primary key. Okay. Blah, blah, blah. You should see another query with the columns. Yes. Let me take a sip of water. Uh, Many times, companies have two sets of users in their database, internal and external. The number in each category tends to be far apart from each other. For example, Wells Fargo has 70 million customers and 258,000 employees. If you were trying to get information about your internal employees, searching through all 70 million records would be a waste when you're looking for a group of users making up about 0.37% of the total. Even with a good index, with this many users, you're wasting time examining far more records than you're interested in. Potential solution to this problem would be to put the internal and external users in separate tables. Unfortunately, this opens up a whole can of worms. Every time you wanted users, you would need to consider both tables, and when looking for both types, you would want to have a union. You would have to union them together. Any changes to the tables would have to be done to both, and in all relevant references to both, doubling the doubling the effort and risk to any change. So then, what's the solution? Well, we can create a partial index. A partial index allows for indexing on a subset of a table, allowing searches to be conducted on just this group of records in the table. So in our example, you would be searching an index of roughly 258,000 instead of 70 million. Think how powerful this addition to your index toolset can be if you find yourself working with massive databases. Okay, so how do we create one? How? With where condition? Okay, all you have to do is create an index like you normally would with a where clause added on to specify the subgroup of data your index should encompass. Let's assume that in our example, the users are stored in a users table, and we want an index based on username. Okay, so if we know that all internal employees have an email address ending in @wellsfargo.com, we would write the partial index like this. Okay. So you need to be working with very large blah blah blah. Let's suppose the company you're working for wants to run regular advertising targeting your teenage customers. Sounds like this might be a good use of a partial index. All right, let's run explain analyze on customers. Searching for records where the years old is a teenager. There's already an index built for years old. Wait, so years old is a number or is it string? Probably shouldn't be querying the entire data table, but or database, but no, 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 don't be stuck. Okay, there we go. Oh my God. Okay. Please don't break. It's frozen now. Okay, let's wait. Okay. My God. Oh. Okay, we're breaking things left and right. Should probably have limited that weary to like 10. Yeah, probably. So years old is an integer. Okay, let's delete that. Let's uncomment this from customers. So where years old is, what is a teenager? Oh, between 13 and 19. This just as you had written where years old. Oh, between. We can use between. Okay. Okay, so that took us 4 milliseconds. Or 4, 4 milliseconds. Okay, so create a partial index on the customer table. Index customers years old teen IDX on customers years old. Now let's take a look. Wait, what? Oh, years old. Right, we forgot the where. Where years old between 13, 13 I said, and 19. There we go. And now we create another query. Okay, so it doubled the speed. Well, not really. It's like quarter faster than before. Ugh. Yeah. Okay. Order by. If you're commonly ordering your data in a specific way on an indexed column, you can add this information to the index itself, and PostgreSQL will store the data in your desired order. By doing this, the results that are... Wait, what? You can add this information to the index itself, and Postgres will store the data in your desired order. By doing this, the results that are returned to you will already be sorted. You won't need to stop. You won't need a second stop of sorting them, saving time on your query. To specify the order of an index, you can add on the order you want your index sorted in when you create the index. Say you have logins table that tracks username and date time each time a login occurs. If you wanted to check to see who has been logging in recently to use your site, you could run yes. But if we were running this query regularly, we could improve the speed by creating our index like this. Yes. You could also use ascending to switch the direction. If your column contains nulls, you can also specify the order they appear by adding nulls first or nulls last to fit your needs. By default, PostgreSQL orders indexes by ascending order with nulls last. So if this is the order you desire, you do not need to do anything. Another way to think of this is that every index we have created so far has had this ordering applied to it without you even knowing the server was doing this ordering. Okay. Say we are regularly being asked for customer email from specific states. The result should be ordered by state name, then email address. Let's start with our standard column index with no ordering so we can compare the ordering later to see the difference. Create the index called customers IDX on customers. We're doing it on state and email address. So state, email address. Okay. So now let's get a baseline for the time it takes to get the data we are after using a multi-column index without a specific order on it. Explain, analyze, select, date, name, email, address from Customers where state name in California or Ohio. And remember to order the results by descending state name and then email address. Order by state name and email address descending. That should be it. Please make sure you're running explain analyze on the correct query. Remember, you're looking for state name, email address, sorting by state name, descending, email address, descending. Oh. Okay, what's wrong? I didn't like that I used the in. Okay, fine. I won't. Very yawny day today. Well, I guess every day is. What's up, Mr. Doorway Dog? Sitting in the doorway again? Taking a nap in the doorway? Yeah? Mr. Doorway Dog? Bum 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 bum. Now create the ordered multi-column index for the scenario so we can compare. Didn't I already do that? Multi-column index. Oh, using the ordering thing. Okay. Create index. Customers. Date. Name. Email. Address. Ordered. IDX. These index names are getting out of hand. On customers. Date. Name. Mail. Address. And then we wanna order by state name, sending, and email address. Ascending. Okay. Eh. What's the problem? Syntax error. Order by. Oh, you don't need to write the order by, you just do the thing immediately here. Oh, okay. Okay. So now let's compare the runtime. Same thing, right? Before, below, blah, 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 blah. See change runtimes as a reminder. Okay. It's decently faster. Like twice as fast. Okay. Quicksort memory. Oh, he's using quicksort. All right. So good to know that we can create indexes that are already pre-ordered. PostgreSQL automatically creates a unique index on a primary key you have in your tables. It will also do this for any column you define as having a unique constraint. Interesting. A unique index, primary key, and unique constraint all reject any attempt to have two records in a table that would have the same value. Multi-column versions of these would reject any record where all the columns are equal. All right. Recall that to view any indexes already associated with a table, such as products, including the index automatically created by the system upon creation of a primary key, there is a system view you can query against. Yes. So, as a note, primary key index standards is to end in PK instead of IDX. To identify it is a specific type of index. It is also the way the system names it when created automatically. Can't get comfy, huh? Come here, I'll pet you. Come here. No, you don't wanna. You're comfy on the floor. Or, come, give you a pet. No. He's like, dude, I'm trying to sleep here. Don't bother me. Okay, the primary key for the customer's table has been removed by a careless developer. Please recreate it on the customer ID. Wow, what a careless schmutz. So, create index. Customer ID key on customer ID. What a careless schmutz. Wait, what? Use alter table. Oh, they removed the primary key itself, not the index. Okay. Alter customer ID primary key. I think that's how you do it. No. No. I forgot the syntax for it. Add primary key. Yeah. Examine the table structure to see that an index exists on the primary key you created. Select all from PG indexes where table name equals customers. Oh, table name. Yep, it's back on. Clustered index. We learned in the previous lesson that an index is an organization of the data in a table. A table can have many indexes. To expand on this, all indexes are either a clustered index or a non-clustered index. For now, let's focus on a clustered index. A clustered index is often tied to the table's primary key. When a clustered index is created for a table, the data is physically organized in the table structure to allow for improved search times. Is physically organized in the table structure to allow for improved search times. Okay. You can think of a clustered index like searching a dictionary. In a dictionary, the data or words and all the related information are physically ordered by their index. Okay, just like dictionary, you can seek your word by quickly jumping to the letter in the alphabet the word you're looking for starts with. Then, even within that letter, you can get a good idea of how deep in that subset your word is probably going to be. Bat will be near the front of the B, while burgundy will be near the end. Right. Oh my god, so much reading. Friday is kicking in. This is how clustered index physically organizes the data in your table. Reorganizing it would allow faster searches. Because it is physically organizing data in the table, there can only be one clustered index per table. In the next exercises, we'll look how non-clustered indexes are different. When the system creates, alters, or refreshes a clustered index, it takes all of the records in your database table that are in memory and rearranges them to match the order of your clustered index, physically altering their location in storage. Then, when you go to do your searches for records based on this index, the system can use this index to find your records faster. Something to note that PostgreSQL does differently than other systems is that it does not maintain this order automatically. When inserting data into a table with a clustered index on other systems, those systems will place the new records and altered records in their correct location in the database order in memory. PostgreSQL keeps modified records where they are and adds new records to the end regardless of sorting. So if we want to maintain the order, we must run the cluster command again on the index when there have been changes. This will recluster the index and put all those new records in its correct place. My god. Because PostgreSQL does not automatically recluster on insert, update, and delete statements, those statements might run faster than equivalent statements using a different system. Well, sure. But then your select statements probably going to run slower because, yeah, you're looking at unordered data at that point after enough insert and update delete. Well, even after one insert, update, or delete statement. The flip side of this coin is, though, that after time, the more your table is modified, the less useful the cluster will be on your searches. Yeah. Reclustering the table has a cost, so you will need to find a balance on when to recluster your tables. There are tools that can be used to help you identify when this would be useful, but these tools fall outside of this lesson. To cluster your database table using an existing index, say product name IDX on the products table, you would use cluster products using, okay. If you already established what index should be clustered on, you can simply tell the system which table to apply the cluster on. What if you have already established what index should be clustered on, you can simply tell the system. And if you want to cluster every table in your database that has an identified index to use, you can simply call cluster. Okay, so let's say the table we created a primary key on is in the previous lesson is most often searched by this column. Let's create a cluster index on this column. The index customer last name IDX already exists. Please make it a cluster index. So we do cluster customers using customers last name IDX. Yeah. And let's say that the customers table we just created a clustered index on has had a significant number of changes and now needs to be reclustered. So if we can just do cluster customers. No. Yes. Cluster. It's cluster, boy. My man. My pal. My chap. Ugh. The speed at which you get information in this is a little bit exhausting. Or maybe it's Friday. Okay. We are trying to keep an eye on our warehouse to ensure that they are near as many of our customers as possible, and we have to check regularly as we gain and lose customers. Oh, never mind. I have to read the whole thing. Let's take a break. I'm like suddenly feeling very exhausted. So, 10. There we go. Okay. You can create many indexes on a table, but only one can be clustered index. Right, you already told me that. So what about the rest? They're known as non-clustered indexes. Non-clustered indexes have records of the columns they're indexing and a pointer back to the actual data in the table. Maybe we'll play something. Bought Cyberpunk 2 months ago and not played it yet? Oh, well, I don't know. I tried Cyberpunk. Maybe it's because I played it right after release, but it wasn't really my cup of tea. Maybe it's better now. I don't know. In terms of playing, probably like we usually do games on weekends, and for the past couple of weekends we did Elden Ring, but probably this weekend, excluding Saturday because I won't be at home, so I won't be streaming. But on Sunday we'll be doing probably. I saw this interesting game called Balasto. Wait, what's it called? Balastro. Balatro. Yeah, Balatro. Which is like a roguelite poker game. So that will be interesting to check out. Please don't show me any streams. Yeah, it's basically a roguelite poker game. So this will be interesting to check out. Another one I want to try out is Backpack Battles. Backpack Battles. Yeah, this one. It's like inventory management battle thingy. Oh, it's in early access. Like I have such an allergic reaction to early access games now these days. Because most of them are just like you pay the full price for a game and it's not even finished. Like what's up with that? It's online PvP basically. So we might try that as well. But that's gonna be on Sunday. But yeah, Cyberpunk is good. Like I don't know how many games you played like Cyberpunk. Like have you played Skyrim? Or like Fallout? Or what other open world RPG games are there? Yeah, so you'd probably enjoy Cyberpunk. It's a little bit confusing in the beginning, but once you get going, it's pretty fun. I guess the reason why I didn't like it is because without spoiling the story too much, right? My idea of an RPG is having a character and then building him out and then just like snowballing into godhood level essentially. Where eventually you're just like overpowered for the entire game and you're just blasting everything and doing whatever you want. That's my idea of a good time. You can't necessarily do the same thing in Cyberpunk, as far as I know, because of how the game is built in a sense. So, but you should enjoy it. I'm sure you will. Okay. Love Death Stranding. Played in Cyberpunk on PS4 Slim and done it. Oh, you already played Cyberpunk. Okay. I haven't played Death Stranding yet. I heard it's great, but am I correct in assuming that it's sort of a story based game that's kind of a walking simulator? Because if that's the case, ah, I don't know. Maybe it's not for me. And it's a beautiful story. Okay. Well, might play it someday. Not, but not while I have other games on the back burner. All the music starting when you are goes over hills, and it's beautiful. Yeah, I imagine they to make to make a game like Death Stranding work, there have to be other aspects besides the gameplay itself that drive it forward, such as storytelling, music, world building, and so on and so forth. So yeah, as popular as it is, I imagine that it slaps. Okay, so if you are searching just for the records in the non-clustered index, the system will simply seek for your query results and return them. When you search on a non-clustered index for more information than is in the indexed columns, there are two searches. The first to find the record in the index, and another to find the record the pointer identifies. Hmm. Okay, so there are some things you can do, such as creating a multi-column index that in some cases can help out, cut down, or eliminate the need for the look back to the main table in memory. Previously, we compared how a clustered index functions as a dictionary. You can think of all the other indexed, non-clustered, uh, all the other indexes that are non-clustered more akin to an index in a book. Okay, so the keywords you're looking for are organized by type, alphabetically, by the number of appearances, etc., and can be found quickly. However, the index doesn't contain information beyond that. Instead, it contains a pointer to where the rest of the data can be found. This is the same way non-clustered indexes in the database work. You have a key that is sorted and a pointer to where to find the rest of the data if needed. In the next exercise, we will go over ways that this pointer look back can be avoided altogether in some cases. For now, the main takeaway is that clustered index contain all the information in your table and physically reorganizes the way it is stored in memory. A non-clustered index creates a key on the columns you indicate and a pointer back to the main table for any columns not part of the index. Not. I read things and I'm not understanding them. Like what I'm reading makes sense, but I'm not understanding them. By the way, Tiberian, we broke Codecademy today. Let's see if it works now. Like one of these exercises, there was a project, and I think we queued a little bit too much information. Oh, it's working now. Okay. All right, so we can finish this later. Yeah, basically we tried to run this and it just broke. And we got an infinite disconnected from Codecademy message despite reloading the website and the browser. But it's working now. Okay. So we are trying to keep an eye on our warehouses to ensure that there are near as many of our customers as possible, and we have to check regularly as we gain and lose customers. Create an index for filtering on state name. Call it customer state name IDX. Remember, PostgreSQL defaults all indexes to non-clustered unless you specify one to be clustered. So you do not need to do anything special when creating your index for it to be non-clustered. Okay. Create index customers state name IDX on customers state name. Let's use our index now to find the last name of everyone in Texas, ordered by last name. Think about what information is found in the index and what information the database server uses the key pointer combination to find the information in the table. In order to pass this step, you have your query return last name followed by state name. Okay, so select last name, state name from customers where where state name equals Texas. Order by last name. Okay. Please don't break $1 million company. It's not good. Like, I don't know what I broke because what are we trying to do here? We were trying to explain, analyze, select, and then try to look at the size of the index or the file. And then we try to create a multi-column index. Let's try and run this again, see if it breaks again. No, it was fine. Okay, so blah, blah, blah. Let's repeat the process. Get other impacts of an index, such as impact, blah, 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 blah. Okay, so just because we created a multi-column index that increased our file size by 50% roughly, but it lowered the execution time by double. So that's good. Okay. Let's move on. Are they multi-million dollar company? Are they traded publicly? Do they have public stock? No, I don't think they do. Academy value. Company. $525 million. God damn. They've been acquired by Skillsoft, though, in 2021. Yeah. Well, it makes sense. Their material is pretty good quality. And the fact that they give out certificates, even though these certificates are like, meh, they're not really, you know, university or a college or whatever official institution level, but they're still something because to get them, you actually have to go like pass exams within Codecademy. So like if we were actually still learning this backend engineering module in its entirety instead of skipping on the things that are relevant to me, we probably would be taking an exam now because we have the software engineering foundations pretty much finished and only these two things left. And then you take exams. And then the same thing here. You pass all the in between the exams, you also have to do projects, you also have to do exercises, so it's an actual like on hands experience in a sense. As limited as it is, still it's better than nothing. And then after you finish all this, you get a certificate that sort of says like, hey, like look, this person went through all this theory and all this practice, so they know something. So it's at least some kind of proof. Okay, the lookup that a non-clustered index does back to the table after finding records has a cost. If referencing a small number of records, this cost is negligible. However, it can add up if many records are needed. If all columns being used in a query are part of an index, then no secondary lookups is done. Let's examine the following multi-column index. Okay, last name, first name. This will improve the speed when searching for customers by last name and first name. What happens when we frequently want to know the customer's email address as well? For each record found, it will use the index to find a pointer and then look up the email address matched to that record. Oh, okay, finally, I understand it. So the index just points to. No, the index finds whatever is indexed. And then based on that position, we look back to the original table using a pointer, and then we find the everything else that's not indexed. Okay. So if you include the information that is regularly looked for, even if it isn't used in the filtering as part of the index, a secondary search can be avoided. So in this example, you could add email address as another column in the index to prevent the lookup step. Remember, the order the columns are in when creating the index should be whatever is most useful for your particular situation for searches and filtering. Yeah, significantly improve searches over tables. Yeah. So there's so many things to think about with indexes. It's like the first thing is like, is the index necessary? Then the second thing, prevent insert duplicate records if index is unique. Yeah. Second thing is like, uh, whether it will actually improve things. The third thing is whether, even if it improves things, whether you're not going to get hurt in some other area. like storage, for example. Then you have to figure out what kind of index you want to create. So multi-column, single column, on what column in general, how many indexes, like indexing is a handful. Remember the order, blah, 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 blah. Okay. So there's already an index on last name. Let's run a query with explain analyze, looking for first name, last name, email address, and where last name equals Smith. If you create a lot of indexes over one table, even more than columns, you're doing something wrong. Well, yeah, of course. What I'm trying to say is that it's very, 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 very situational with indexes. And it's probably not something you have to worry about when creating a database. Only when people start using it, you have to analyze how people use it, whether what are they often looking for, what are they querying, is the database being updated often, or are just people just looking at the database? Okay, so let's explain, analyze, select. We're looking for first name, last name, email address from customers where last name is equal to Smith. Indexes are cheap to create and use. Don't be scared. I'm not scared. I'm just saying, like, to create a because sure, you can create a bunch of indexes, um, but then you have to make sure that they're useful. So you have to do testing, like with the explain analyze thing, and with the size to weigh the pros and cons of each index that you create. Otherwise, like if you're working on a massive database, it's just basically a waste of time and money to have a bunch of indexes that are not necessarily doing anything. Do you work with it? Do you work with indexes often? So create a new index based on the example index to provide a secondary search when looking for first name, email address based on last name. Put the columns in the order of the name. Not working with databases without indexes. Oh, okay. Okay, so it's a pretty big part of working with databases then, it seems. Its main part? Oh. Oh. Okay. All right, so on customers, and we do first name, email address, and last name. Put the columns in the order of the name. So first name, No. Last name first. Oh. Okay, so let's create another explain. Analyze. So you should have one before and after. You can see the index. The search should be, again, looking for first name, last name, or last name, blah, 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 blah. All right, let's compare. Okay, so it cut down on the execution time roughly by double. Okay. Uh, well, sure. By the way, we had a burning question like what's the typical database size in like a normal any kind of given normal company? Like I didn't really found a conclusive answer, of course, because it's very situational based on the company and what the company does. So from now on, I'm gonna ask everybody who's like working with databases, like what size of a database are you working with? All right, previously we went over multi-column indexes as a way PostgreSQL can speed up searches on multi-column filtering. But if you don't have an appropriate single index for a query, the server can combine indexes together to speed the filter. Weird way to say it. To speed the filter. To speed up the filter, maybe. Like anything automatically handled by a system, there are some things to keep in mind when using this convenience. A single multi-column index is faster than the server combining indexes. Okay. If ordered well. A multi-column index is less efficient than a single index in case where a single index is needed. But actually, like we did take a look at. Okay, yeah, makes sense. Multi-column is less efficient than a single index in cases where a single index is needed. Ah, okay. You could create all of them, two single indexes and one column index, and then the server will try to use the best one in each case. But if they are not if they are all not used relatively often or equally, then this is a misuse of indexes. Okay. Take, for example, searching for first name and last name in the customers table. If searches are most often for only one of the columns, then you should use that single index. If searches are most often last name and first name, then you should have multi-column index. If the searches are frequent and evenly spread among first name alone and last name alone, and the combination of the two, that is a situation where you would want to have all three indexes, two single indexes and one column index. Okay, makes sense. So let's examine the runtime of customer's query where last name equals Jones and first name equals Steve. The system should be combining first name index and last name index. Explain. Did it explain? Analyze. From customers where last name equals Jones. And first name equals. Excuse me. Steve. Stever. Okay, so it's decent. We have 0.078 execution time. As previously mentioned, a multi-column index is faster than the server combining indexes for you. Create a multi-column index for last name and first name on customers. Okay. Last name and first. And let's run the explain query again to take a look. Okay. I mean, it's a little faster, but nothing to write home about. Hmm. Okay. Well, what if we queue up like last name and first name? And wait, same here. Yeah, pretty much the same difference, really. Actually, does selecting everything and selecting just two columns? No, there's not much difference. Okay. Indexes based on expressions. An index is not limited to just a column reference. It can use the result of a function or scalar expression computed from one or more columns. For example, if you want to ensure a company name in a manufacturer's table is unique, you can add the unique option to make a unique index constraint on the results on your index. Any duplicate will be then rejected. Using unique here tells the system that your index also needs to be a constraint and only allow one record in the system that matches the criteria for your index. In other words, by creating an index with unique, the system will automatically create the constraint to match the logic in the index at the same time. Okay. So just like the creation of constraint, if you try to create an index in this way, where the data already is in the table does not pass, the system will reject your creation and notify you of the issue. Okay. So let's look at our unique example a bit more. In PostgreSQL, example company is not the same thing as example company, yeah, because it's case sensitive. Even though we would probably want to reject this as a duplicate. Ah, I see. You can add a function on your index to convert all your company name data to lowercase by using lower. This ensures that the example company would be considered the same as example company. This combination of the unique constraint and the use of the function lower would look like this. Okay, so we create the index as usual on manufacturer. Lower. And we put the column name into lower function. Okay. These special indexes compound the pros and cons of indexes. Because the results of the expression are stored in the index, it saves the search function from having to perform it on every row on future searches. However, every change in the table data that impacts the index means it has to do the expression again. making inserts and updates more expensive on these indexes than a basic index. Be especially thoughtful about when to use indexes, then use functions or expressions. All right. So let's say our site wants to ensure that all email addresses are entered by users when creating a new account do not already exist. Create a unique index to quickly search and verify this. All email addresses entered by users when creating a new account do not already exist. Okay, so create index customers email address lower unique. Create unique index. And then we just do on customers lower and email address. No? No. IDX. Okay, let's check to make sure that the constraint and index are working correctly. Try to insert duplicate emails with different capitalizations, such as tests at sample and test at sample, which we would expect to fail. In the table creation script, the first name and last name fields were declared as not null, which means they're required to contain information, so we will need to put in those as well. All right. What was it? First and last name? Name, last name, and let's do email address. You gotta spell address correctly. I'll use, so let's say John Dick. And this will be the first email. And then John Key will have following email. If you did this correctly, you should see an error message. Yay, duplicate key value violates unique constraint. Okay, makes sense. Because now these are duplicates. Because a unique thingamabob has been placed on the email column and also is checking for a lower email address. Okay. Review. Okay, let's move on to the quiz and a project after that, probably. In PostgreSQL, the cluster keyword can be used to create a new cluster index on a table. Recluster a table already set up with an index. Or recluster every table in a database that has a clustered index already identified. How do we do each of these? So, first of all, create a new cluster on index, clustered index on a table. We do cluster table name needing a new cluster, table name for recluster, index name. Table name needing a new cluster, and we do index name. And then table name for recluster and just cluster. Okay. A partial index allows for indexing on a subset of a table. How do you create a partial index? So create an index name on table name and the condition where columns. Yep. Wait. Oh, these should have been the other way around. My bad. What are the two types of indexes in PostgreSQL? Fast and deep, nullable or non-nullable, primary and foreign. It's clustered and non-clustered. A table can have multiple non-clustered indexes. True or false? These indexes always include all the information needed about the record. False. PostgreSQL can use indexes to return results in order without a separate step to sort. What control does this give you when creating an index? Can use indexes to return results in order without a separate step. Oh, so using this, you can specify if the rows are ascending, descending, and nulls first, last by each column in your index. Sure. But so does ordering normally. This allows you to only index records that are populated and filtered out based on the conditions you enter. Allows you to ensure the records are accurate against local check. Done so efficiently. I knew it. True or false? In PostgreSQL, when a primary key is created on a table, the database server automatically creates a unique index on that table. A unique index. Yeah, it's true. Every day, your marketing department needs a list of all order information from orders for orders from specific cities for targeted advertising. Your company does a steady stream of business with thousands of orders a week. However, your business is very regional and only has sales to customers in a few cities. What indexes should you create to best handle this situation? My brain is shutting down. All right, let's take it slow. So we need a list of all order information. Does a stream steady of business? Thousands of orders a week. But it's very regional and only has sales to customers in a few cities. Okay, so an index with all the columns in the table, starting with order date, then city, to prevent secondary lookup. An index for order data and for city. A single index for order data, possibly adding city to that index after testing. No index is needed as this query does not occur often enough. It's pretty often. Okay, let's think about it. So, an index with all the columns in the table would be quite intensive and a little bit of an overkill. And the time we save on the secondary lookup or on preventing a secondary lookup is probably going to be wasted on the fact that we have all of the columns in the index. An index for order date and another for city. Is probably unwarranted as well because there's only a few cities. I'm going to go with this one. Single index for order data and possibly adding city to that index after testing. Yeah, hey. In this situation, your filtering would be most effective on the date due to the percentage of records that could be quickly filtered out by an index of the order date. Yeah. A partial index allows for indexing on a subset of a table. How do you create a partial index? So index name, table name, and then we do columns and then a condition. Yeah. Table can have multiple non-clustered indexes. True or false, these indexes always include. That's false. In PostgreSQL, non-clustered indexes consist of a key and a pointer. What does the following code not need to use? Why does the following code not need to use its pointer when getting the information? It is because it's querying for the information that's already in the index. What are the two types of indexes in PostgreSQL? Clustered and non-clustered. Okay, PostgreSQL can use indexes to return results in order without a separate step to sort. What control does this give you? Which one did I select? Sure that records are accurate against. No, this allows you to only index records that are populated and filter out others based on conditions you enter. Use indexes to return results in order without a separate step. Using this, you can specify if the rows are ascending, descending, and nulls first, last by each column in your index. Only index records that are populated and filtered out. Filter out the others based on the conditions you enter. No, this is a partial thing. This one. Partial indexing. The cluster keyword. Oh, it's just creating clusters. So cluster the table needing a new cluster, index name, and then cluster for your cluster, and then a semicolon. What is the purpose of the following index? So we're creating an index on customer full name index where what? First name, empty column, and last name? Creates a multi-column index of first name and the last name. This combines the first and last name together. So all filtering of full name will not have to do the logic on every record compare against, as it will be stored combined. Or is this not a valid index? I'm going to go with this, even though I didn't really know the answer. Okay, we have a project on our hands. Actually, we have two projects on our hand. The one that we didn't finish because it broke, and then this one. It's a bookstore again. Okay, two bookstore projects waiting for us after lunch. because I'm tired. I'm getting tired, and I need a longer break. So I will see you guys after. Well, I'm back. The walk with Tor took a bit longer today because we met a friendly Labradoodle. Well, not a Labradoodle, a Labrador Retriever. He was quite bigger, quite a lot bigger than Thor. And I don't mean to badmouth other dogs, but he was a bit unruly. So much so that he actually. Oh my god. I just noticed. He actually broke off his leash. Like, he wasn't aggressive or anything, but he broke off his leash, and I was trying to, like, catch him by his harness. But he's so much stronger. I did get, I did grab him, but he kind of broke a piece of my nail. I just noticed. I was like, what is this pain in my finger? Okay. Well, interesting stuff happens. Thor was glad. I wasn't when I had to clean the Labrador's paw prints off of Thor. It's actually a bit hurty. Okay. Well, let's move into our project. So let's first of all finish this one. I feel like we should do that before taking on an entirely new project. Oh my god. Still getting the hang of this new boom arm. A bit finicky, but should be fine. Okay, so after running your site for a while, you find that you're often inserting new books into your books table as new books get released. However, many of these books don't sell enough copies to be worth translating, so your index has proven to be more costly than beneficial. Delete the multi-column index we created above to make it so inserts into the books will run quickly. Okay, so we do drop index. Right? I think. Was it drop index? Now I need my cheat sheet. Cheat sheet. clustered. Clustered keyword. Primary, avoiding, ordered, combining, indexes, downsides, dropping an index. Drop index if exists, and then index name. Okay. So we could do drop index if exists. And there we go. Okay, so the company you work for has bought out a competitor bookstore. You will need to load all of their orders into your orders table with a bulk copy. Let's see how long this bulk insert will take. Since the syntax on how to do this was not part of the lesson, here's a script that will take the data from the file orders add.txt and insert the records into the orders table. Explain analyze doesn't work on copy calls, so we're using a timestamp before and after load. After we load the information into the database, make note of the time difference between the two timestamps as they will get erased on the next task. Sure. Okay, so timestamps. Here. 0.3 milliseconds. 0.3 seconds, actually. Okay. So now go back to your copy function. And before you get the first timestamp, drop all of the indexes you've created so far on the orders table in this project. Then, after the second timestamp, recreate them. Look at the time to do the bulk now. Right, we have this index here. When we dropped it, so we don't really have this index anymore. As a note, the Codecademy website clears and rebuilds the database you're working with every time you hit the save button. If you were to run this code on another database server, you would hit duplicate error, insert error, since you would have already inserted the books from the blah 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 blah. Okay. Okay, your boss tells you that you need to build an index on the customer's table with first name and email address. Your boss says people keep asking for contact information for clients. Before jumping in and creating the index, try to answer some of these questions. Is this a good idea? Uh, Customers, first name and email address. Well, since probably customers get added quite frequently, I would imagine. So any index directly messing with first name and email address is going to slow down the insertions. What would you need to check to see if this would help the system? All the runtimes, the storage. What questions would you have to ensure it is a good use of an index? What suggestions might you make? What negative aspects of creating it would you bring up? Okay, you honestly don't have enough information at this point to say if it's a good or a bad idea. In this very specific case, the size of the database probably doesn't warrant it, but it also probably won't hurt much. So this might be a case where a little good bad it causes might be worth it to make your boss happy. You would need to see the specific queries your boss is using or having someone else run to get the information and do a comparison of the runtimes for these as well as other queries that use the customer's table to see how they're also impacted. You should think about what your boss hopes to accomplish by doing this. You have had training now in what indexes are and what they're for. Most people have not. They may hear the jargon and just think it makes queries faster without knowing any of the side effects. Oh, I'm getting a call. 1 second. People are impatient. Okay, so where were we? Uh, they may have heard the jargon and just think it makes queries faster without knowing about any of the side effects. It would be your job to make sure you find why did I say find out so southernly? Find out. Find out what they hope to accomplish and inform them of any possible consequences for it. For instance, your boss might want queries faster to get customer contact info. But if it impacts customers creating their own accounts, your boss might decide it's not worth it. You might be able to make the index even more useful. You could find out if the last name should be included as well, or if any other columns are regularly used along with this information. Some downsides of creating this index are the increased size of the table and speed impacts on insert, update, and delete records. In this case, these would directly impact your customers, so it would be critical your boss is aware of this possible impact. Well, okay, very open-ended question, to be honest. Okay, so we're done with this. Now we can jump into this. Before we start having fun with the database, familiarize yourself with what we are starting with. Look at the first 10 rows in each table, customers, orders, and books, to get a feel for what is in each. We already kind of did that, but okay. And books. All right. Pretty standard stuff. Why is it shuffling my playlist when I have shuffle turned off? Bum 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 bum. Oh, keeps turning on and off, on and off. Wait, all right, let's wait to see what it settles on. The audio might be a bit too loud too. Yeah, there we go. I forgot, I turned it on, turned it up for lunch break. Okay, so it finally stopped doing its thing. Shuffle is on now. And now it's off. Okay, good. Wait, what's happening? Oh, there. Okay. Very scatterbrained day. Righto. So, before making any changes to the database and its tables, you should know what you're working with. Examine the indexes that already exist on the three tables. There are indexes of note, book's author index, and book's title index. We will get to use we will get to their use soon, but for fun, you can guess what we will be using them for. It also appears that an index is missing. Ah, let's try and remember how to do that. So select all from PG indexes where table name equals, you can do in customers orders and books. Okay, so we have books primary key, orders primary key. What about our customers primary key? It ain't there, even though it should be. Your marketing team reaches out to you to request regular information on sales figures, but they're only interested in sales of greater than 18 units sold in an order to see if there would be a benefit in targeted marketing. They will need the customer IDs and quantity ordered. Okay, so let's perform an explain analyze. Get the information where quantity is greater than 18. Okay, analyze, select customer ID, quantity from customers. I think it's customers. Customers. No, it's orders. Orders where quantity is greater than 18. Okay, so that took 11 milliseconds. No, 11 seconds. Didn't take that long, but okay. Without an index. Because we know they are only ever interested in orders where specifically more than 18 books were ordered, we can build an index to improve the search time for the specific query. Okay. Sure. Create index. Quantity. Well, orders quantity over 18 IDX on books where quantity is greater than 18. This works? No. What are we missing? Combining ordered partial index. Partial. It should work. Unless we have to put it into parentheses. No. Create index, index name, on table name. Oh. Customers, books. Wait. Crap. On books, I forgot how to write this. And quantity? Uh, you could do customer ID and quantity. What? Column quantity does not exist. You don't exist. What? Column quantity does not exist. Oh, I'm doing it on books, orders. My brain is melting. There we go. So now we should have a new index. Yes, we do. Okay. So now we want to test if it works or how much better it works. So we'll run the same query. Let's take a look. Okay, so before we had 11. Now it's 3. Pretty sure we had 3 before. But okay. I wonder, do these queries mess with the time as well or not? No, not really. Okay, so it's better. What if we do quantity first? Ah, didn't matter too much. Um, yeah, okay. Started project, you were asked if you could find what index was missing. Brain not braining, study not studying, sleep not sleeping, money not moneying. Yeah, you do be that like that sometimes. Like I went outside with the dog, and I don't know if you heard this when I came back from the break, but I went outside with Thor, and the usual spot where we go to do his business, there was a Labrador Retriever there. He was quite big too. Um, but the owner, I guess, because the owner was like, I don't know, she was like 60-year-old lady or something, and he was quite big. He's like a beefy Labrador. So he got excited seeing Thor. He wasn't aggressive or anything. He just wanted to play. But in his excitement, he broke his leash, ran away from his owner, and just started playing with Thor. And since I didn't want Thor to get like completely mudded in mud, I tried to grab the Labrador by the collar, and I guess in the process, I somehow like broke a part of my nail. Not completely broken; it's just like cracked. And I only noticed when I came back home. Just crazy. Yeah. Fridays are not for studying. Fridays should be like, I don't know, chill days, officially mandated by the government. We should all be like just taking it easy. Typical dog let's play. Pretty much. Except when the dog is when the dog is trained and well behaved, even if he wants to play, he'll do it like properly. He won't just charge at another dog and then play without initiation or without, because dogs initiate play. They have their own kind of language to initiate play, where they like do that, like either they first approach each other, they sniff each other, then they do like this little play bow thingy, and if the other dog reciprocates, then it's playtime. But this dog, he was just like, he saw my dog. He was like, oh my God, there's a dog. Broke off his leash and then immediately darted for my dog and started jumping all around. And so, not the most well behaved dog, but it's fine. You would think that would be a priority for the owner, right? If she's like 60 years old, she can barely control him. It can barely hold him in place, let alone to stop him from charging. Like, obedience training would be a priority, but I guess not. On top of all that, some schmuck, because we usually pass to go to the area where he does his business. We pass through this like gap between two buildings. So some schmuck overnight just decided to break a bunch of bottles there, glass bottles. So now it's like full of glass there. So we have to walk the long way around. I might actually go after the stream, grab my broom and go sweep that area up because it's just now I have to either go around the long way or carry him through. And I'm sure it's like a problem for other dogs as well and owners. You are a good citizen. I mean, I'm doing it mostly for myself because I don't want this guy to like stab his paws. But it is very annoying when there's like glass all over the place. It's not the first time either. Yeah. Yeah, Thor? You chewing on your toy that you ripped the tail off of? Yeah. 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 Boink. My toy now. You want the toy? Want the toy? Go get it. He's like, well, now I don't want it. Okay, never mind. Okay, so you may have noticed that the customers table is missing a primary key, and therefore its accompanying index. Yes, I did notice. To check the effectiveness of this index, write a query that uses a where clause targeting the primary key field. Sure. What was it? We were missing one on customers ID. From customers. And let's limit that to 100. And so now we want to alter table customers, add primary key to customer ID. I think that's how you add it. Check if the primary key got added. Yes, it did. So now we can take a look at what impact did that have on querying customer ID. So we had 0.046 and now we have 0.043. So not that much, but yeah, probably should not miss primary keys on like ID columns. Okay. You might have noticed that when you got, well, actually, let's take off the limits. Maybe the difference will be more noticeable when we run the queries on the full table. Huh? Syntax error. Oh. Mm. Oh, okay. Yeah, it's something. What if we just comment it out? Should be the same now. No, there's still a difference. What? Maybe the index didn't get deleted. Let's take a look. Please don't break. Please don't break. Oh no, it's breaking. This is how it broke the last time. Like I clicked save and then nothing showed up. And then I tried clicking save again and nothing showed up until it wouldn't even let me click save anymore. Okay, let's let's get rid of this. Let's leave this index here. Get rid of this, get rid of that. Crap. Doesn't let me use like multiple selects of the control. Get rid of this, get rid of that. Get rid of... No, don't get rid of that. Get rid of this for now. Okay. And if we click save, cannot create regular... Yep, that's exactly the same error that we got before. Disk quota exceeded. Okay. And if we try to reload... Nope, still nothing. Okay, we broke it again. Congratulations. Okay, let's move on. We'll come back to it later again. Seek versus scan. Okay, let's learn about the difference between a seek search and a scan search. In this article, we're going to go a little deeper into different ways a database server looks for the data you requested in your queries. We will cover what a seek search is, what a scan search is, when are each of them used by the system, what control you have as a programmer on which method the server will use, and when the system will completely ignore your best laid plans. As a note, we are using the terms seek and scan. However, you should be aware that different database servers use different terminology for very similar things. For instance, SQL Server uses seek and scan. PostgreSQL uses scan, index scan, and bitmap heap scan. Okay, make sure you familiarize yourself with the specific way the server you are working in searches for records requested by your queries and the ways you can improve them to take advantage of the server you are using. So there are two major ways that a database searches for rows. Beatmap on Osu. Hey, Checkum. Welcome back. How's it going, man? This is unlimited select statements. This applies to every type of query that needs to find specific rows. For example, in a database of orders, an update query for orders over 10K would need to search for those records. Two basic ways searches are performed are via seek or scan. Waking up later and later. What's up? Nothing much. Just enjoying my Friday afternoon. Took Thor outside. Encountered a friendly labradoodle who was so friendly in fact that he kind of broke he splintered my fingernail. And we're doing databases. Yeah. So that's cool. Yeah, he broke away from his handler and he started just galloping towards Thor. He wasn't aggressive. He just wanted to play. But then he kind of started like aggressively, not aggressively, but like playfully jumping on top of Thor. And I was like, and it's wet outside and it's dirty, so he was leaving paw marks on Thor because he's white. So I was like, I don't want to clean that. So I started like trying to grab the collar of the dog and pull him away a little bit until the handler ran up. And I guess in the process, I just kind of like splintered the left third of my pointy finger nail. So that was fun. To the owner. Yeah, lady, you 60-year-old lady who could barely control her dog. I need $1,000,000 for emotional, physical, punitive, and all the other types of damages that I can think of that your dog has caused me. American moment, yeah. It's fine. Like it's too common of an occurrence for people to get dogs and not train them. Like you just have to take that into account whenever you go outside. It's the same with car, you know. The first thing they teach you when driving a car is like don't rely on other people knowing what the hell are they doing and what the hell they doing in the road. Like you have to assume that everybody is dumb and just drive with that in mind. At least it's not roaming pit bulls. Well, yeah. I mean, even though I have like pit bulls do have that uh bad reputation, not because they're a bad breed or an aggressive breed or anything. Like they do have that inside of them, but if you train them properly, they can be sweethearts. That thing is scaring the hell out of me. You mean pit bulls? I mean, they're fine. Like, yes, pit bulls do have the tendency to be, I wouldn't even say aggressive. They're just guarding because they're fight dogs. That's their purpose. Well, here's the thing. No dog is going to snap if A, they've been trained properly, and B, they're from a reputable breeder, right? Because that's why you look for dogs from reputable breeders, because then you can be sure that their psychology is okay and that they're not going to snap one day, right? And the other part is training. Is not abusing your dog, is not like both physically and mentally. And then they're wonderful dogs. And that doesn't go just for pit bulls, it goes for every single breed. Like even this guy, he's like sweetness embodied. He doesn't have a mean bone in his body, but if I abused him for years, if I like beat him or tortured him or something, he would get aggressive. He would bite me eventually. Let's say pit owners aren't the brightest people. It depends, you know. There's all kinds of people. And it's really sad that afterwards, you know, you get a pit bull who's been possibly bred inappropriately and then mistreated by its owner, and then they bite somebody and people just blame the dog. It's not the dog's fault. It's very situational. A lot of things are very situational. It's why I don't like people that paint things in very broad brushstrokes. It's like, oh, we can apply this to everything, but no, like a lot of things are situational. Okay, I'm getting preachy again. I'm gonna stop before I bore you to death. we got better music today. Actually, better for me, I guess. Not necessarily better for you, because I finally learned how to split audio tracks so that the music doesn't get saved in the VOD. So that's good. Also got my new microphone arm, which is much better than the previous one. Because the previous one, like, you know how mic arms have like clamps to clamp onto a table? My previous mic arm was so horrible that I needed a clamp to hold that clamp. Clampception, yeah. So now I repurposed it as my camera holding arm. So I don't have to, because previously my setup was really janky. I had I had a chair on top of which there was my poker suitcase, on top of which there was a can of compressed air, on top of which was the camera. That was basically the camera setup. And now I have a dedicated arm for the camera. I also got a pop filter, so hopefully the voice quality sounds a little bit better. I did mess around with noise gate settings and other settings yesterday, so little by little we're improving. Now you got that set up, you need to learn special effects. You mean for the camera or for the voice? Because I can do voice special effects on the fly. Let's see, what do we have here?
How about some Optimus Prime action going on in here? That's actually a good selling point for the stream. Optimus Prime learning programming, SQL databases.
What else? Yeah, it's just basic, generic ones.
Does this actually sound like Darth Vader? It says Darth Vader. Luke, I am your father.
Yeah, stuff like that. Basically sounds like you're waking up. uh, holy crap, am I feeling lazy today? What are your plans for the weekend? Like lots of people coming over today, but everyone's coming over at like different time frames. It's like we had Joey in the morning, then Happy swinged by after that, chatted a bit, left. Tiburian's here now, or been here since a couple of hours, and now Checkham's here. Hmm. How come I have so many Hollywood Undead songs? Like I don't even remember adding them. All right. Let's see if I actually turned off the effects. Yes, I did. Okay. The plan for today is doing these class exercises in TS, finishing the TS course when this week, then this week, and either a new project or starting that full stack course. Ah, cool. Okay. So you're deep in learning, I see, as well as me. Except probably doing more projects than I am. I should do some projects eventually. I don't know. I can't reconcile the time it takes to do a project with the time that I will probably lose not learning or like lose learning or not learning. Front end mentor projects, since I have no idea. Okay. Uh, 1 sec, be right back. Okay. Well, I mean, any projects are better is better than no projects. So I guess you could count the projects that I'm doing as projects, even though these SQL projects are not. I wouldn't classify them as projects. Even the projects before with JavaScript, I would be hard pressed to call them projects, but these are just like, oh, try out some queries, write some queries, see what happens. Okay. There are two major ways the database searches for rows in a table. Right, we already read this. A scan searches through every record in the database. Find the records being asked for. So in our example, if we wanted customers to have spent over 10K, the system would need to check every record to see if their order amount was over this threshold. What you're doing is very nice, but getting thrown out, getting thrown on your own and have to figure out things is next level. Sometimes the blank page hits hard. Yeah. Yes. I mean, if I didn't have like this job opportunity coming up, because they wrote me today, actually, they sent me like the practical exercises too. The practical part of their like um onboarding sort of thing. So I'll be diving hard on that tomorrow because I'll have about 8 hours to kill in between the trips because I'm doing a trip tomorrow. So no stream tomorrow, sadly. But we'll see what they have there. But yeah, if I wasn't doing that, I'd probably finish this Codecademy course and then dive into some actual like full on projects. But I guess the purpose when you're doing self-learning, the purpose of the project is essentially to have something to show the employer. But since I kind of already have an employer, like there's not really a purpose to do projects besides like further self-improvement and just completely solidifying knowledge, I guess. Okay, so database scan searches by looking at every record. On the other hand, a seek uses an index to find the specific records being asked for by jumping to their location and either grabbing the data or, if it's a reference, using it to get the information. Let us look at an example, but this time let's assume that the table has an index and the amount spent. When you search for rows where the amount spent is over 10K, now the system can jump almost immediately to the records you're searching for. Yes. Find it crazy that they contact you back, give you instructions and such. That's actually really cool. Yeah, it is. That's why I'm so keen on working for them, to be honest. Because I'm what like they would have no problem finding uh a developer for themselves that knows more than I do and has more experience, but they're like, okay, this guy, like he seems to be driven, motivated. Let's give him a chance. The flip side of that is that I actually have to put in the work to meet the requirements. Like I actually have to go through that training, after which I will have a technical interview And only if I pass that and the training, then I can they will employ me. Mm, 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 mm. This is a trick question. There's no such thing as a seek in a database. Yeah, it's fair. Absolutely. And I have no problem in putting in the work, to be honest. I've done it before in my career stuff. So I know I can do it as well. It's just a matter of time. And if they're willing to give me that time, then that's fine, you know. And if they're not, it's also fine because I'm learning in the process. Even if they don't give me a job, you know, what's the worst case scenario? I learn something new that I can put on my CV and be like, hey, I know this stuff. When does the server decide to use one over the other? In general, the database server will use a seek or scan based on the specific query, and it makes its best guess on which way would be faster. This is the part of the pre-processing that a server does before it actually runs any query you write. For instance, if you are doing a search on a primary key column for a limited subset of the entire database, entire table, the server will most likely use a seek to jump right to the records. Yes, because there's already a primary key index associated with the column. And if you're looking up table records by columns with no index or for a large percentage of total base, the server will most likely use a scan. In these cases, the system would have to look at all or almost all records anyway, so using a seek won't affect any benefit, wouldn't offer any benefit, and could possibly take longer. Even if not employed, you could still ask for 1 to 2 months stage. This is how it's called. They're not sure for you, or you just work for free and get knowledge, so it's a win. I mean, yeah, sure. I think it's staging. Yeah, but I don't know. I feel confident. Just having the confident mindset is half the win, to be honest. Because especially for me, I've learned that if I start like having self doubts, if I start like negatively talking myself down, then there's no point. Like nothing good ever comes out of it. More Hollywood Undead. Jesus Christ. No, it's doing shuffling again. Stop shuffling. Me every days. Well, put it on your to-do list. Stop negative self-talk. Every day I'm like, God, dude, get good, noob. You're good enough, check him. You're good enough. Okay, so if your query is filtering records on an index, but the number of expected rows from the table you're searching on is about 85%, which search method will the database most likely use? Scan. Okay, so what can we do? A seek can only be done when the database server has an organized way to search through the target and table view. This is done by having an index covering your search criteria. Make sure you plan your database table views with good indexes, including primary keys, to increase the chance that a seek can be used to improve the efficiency of queries. Okay, here's an example of when a scan and a seek would be used by a server. So this is a scan because we're just like looking up the entire table. Because the query is looking for every record in the table, the server will use a scan to search through every record. But if we're narrowing it down to only show queries where city is Pittsburgh, it would use a seek, assuming the customer table has an index on city and customers in Pittsburgh don't make up a large portion of all the records, jumping almost instantly right to the specific record you're searching for. The worst is that I know I'm 10 times better than what I was when I finished my degree, and even then my teacher was telling me that I was good enough. But brain doing its magic, I guess. Coffee time. Well, I mean, there's ways to get that under control, but you would probably have to go to a therapist to help you work through that, because it's very much doable, but you just have to practice it and be dedicated to it. All right, good coffee time. This would use seek, yes. Okay, as a developer, you have no control over if the server uses seek or scan. False. What is out of your hands? The database server decides if it should use seek or scan. This means that even if you write your query to take advantage of a good index, the server might ignore this and run the query using a scan. Ah, but why would it do this? If you're examining over 50% or 50% to 70% of the records in the table, then seeking no longer offers any advantage. If you are regularly skipping the benefits of your indexes, they might need to be re-examined to see if the costs outweigh the benefits. Okay. This is very similar to the example we had before where we search for records equal to 100. But in this case, we're looking for all records greater than 100. If our database has reasonable number of clients, for instance in the thousands, then the system will ignore the seek option and instead scan through every record in the table. The server will predict that the number of rows returned will be large enough that seeking for each match would not be any faster. Class is exercise time. Fairly easy later. Thanks for stopping by. Good luck at your exercises. See you later, man. Okay. Bonus tip for speeding up queries. If you're searching the same set of records from a table view more than once in a block of code, put the filtered rows into an object such as a temporary table variable, or view depending on the situation. This will eliminate the need to have to search the table for the same set of records more than once. As a small example, you could search for two different things in a database of book orders, both of which need the same set of customers and their orders, but are restricted by the books. I did not understand a single word in that sentence. A small example you could search for two different things. You could search for two different things in a database of book orders, both of which need the same set of customers and their orders, but then are restricted by the books. Okay. So select this from customers, orders on customers ID, join, where state name equals Texas and original language check. Okay. Alternatively, you could create a temp table and filter the customers and their orders first. Since you want the same set of information in both queries, This saves the server from repeating work. Oh, because, okay, so since we are, right, since we are, create table my temp first, whichever, blah, 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 book ID. And then we insert the first query as a table into the temporary table. Then we do the second query. Wait, from my temp? Oh, okay. So yeah, we do the Texas one first because that's a state name. And the only difference between these two first queries is the original language. So then we can do that on the check language query we can do on my temp table, which is already sort of preloaded and pre-searched, I guess, and is going to be smaller than the original table. And then do the same for the publisher year. Okay. I gets it. I gets it. I'm smart person. All right, normalization. Let's take a break before we tackle normalization. We're slowly shutting down, Jesus Christ. Because that's another big topic, I think. Oh yeah, an hour and 15 minutes, which translates roughly into 3 hours of normal human time. Okay, let's take a break. I will see you in 10. We're back. Let's finish this bish up. Bish, 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 bish. Okay, so imagine that you are tasked with designing a database to store student, faculty, and curriculum information at a college. Currently, the school is storing data in a single table. Each row of the table represents an individual student. The column names are listed in the schema below. The following exercises will examine some of the inefficiencies associated with the structure of this table and think about possible ways to remedy the situation. The process of restructuring a database in this way is called normalization. If you look up database normalization, you'll see that there are formal names and definitions for different levels of restructuring. Most common are first, second, and third normal form. 1FS, 1F, NF, 1NF, 2NF, 3NF. In practice, the formal vocabulary tends to be used in academic settings and would be important to understand if you want to read a paper about how to optimize your database schema. Database engineers think about the underlying concepts of normalization on a day to day basis, but rarely use the technical names and definitions. Ain't that truth for everything? Half the terminology you learn in university, you can toss it out the window as soon as you get your diploma. This lesson is therefore focused on ideas behind normalization rather than the formal vocabulary, although we encourage you to do your own research if you are interested in learning more. Before we get started unpacking the college table described above, let's first query it to get a sense of the data. Remember that you can return all columns of a table using select. Yeah, it's basic stuff. You shouldn't have to remind us of this at this point. Okay. So the college table has been loaded for you. Write a query to print first 10 rows in the table. Okay. College limit 210. So Kyle Rollins, a senior, studying neuroscience, majoring neuroscience and English. Ugh. I studied English. I quit after the first semester. It was not fun. Next, duplicated data. Let's now examine the college table from exercise 1 more closely. Ah! Yawning. The primary key of this table is student ID, and most of the columns describe characteristics of students, including their name, class year, email, majors, and advisor. This table also contains columns that do not describe students directly. For example, the columns advisor name, advisor department, advisor building, advisor email describe further details about advisors. Meanwhile, major 1 credits required, major 2 credits required describe further detail about majors. When columns of a database table do not depend on, or in other words, describe the primary key, the same data may be duplicated in multiple places. Yep. Well, I mean, okay. Let's read on before I start like picking at words or ideas. For example, if all students who share an advisor will have the same information listed in these 4 advisor related columns, in future exercises we will see how this can cause problems related to data modification. Okay, no, I thought about it and I take back my word. I was going to say that even with a separate table that has a foreign key, you're still duplicating the foreign keys. But at the same time, I realized that instead of 4 columns, you only have 1 column doing that. So that's still probably preferable. Oh my god, stop shuffling. And it's like shuffling badly. It's like only playing top, I don't know, top 15% of the songs. Uh, okay. What are we doing here? Remember that you can use a where clause within a select statement to return rows of a table where a particular condition is met. For example, the following query would return all sophomore student names and emails. Sure. Ah! God, I'm getting sleepy. Hmm. Ah. I envy Thor. He just gets to lay around all day. It's Friday. Gonna become a catchphrase of this channel. It's Friday, so we get to lounge around and do nothing. Well, I guess we're doing something. Okay, the college table has been loaded for you. Professor Bunsen is a popular advisor from the chemistry department. Use select statement to where, blah, 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 blah. To select and where cause. Select columns for all students with Bunsen. This is a sure. Hmm. Department. Yes. What is it with me and all constantly misspelling where? D- hmm. What is it from department? Department. Department. I even stopped at this word because I felt something was wrong. Ugh. Okay. Brunson. Below your query from step 1, write another query to return major 1 and major 2 credits required for all students with major 1. Okay. Computer science. In the last exercise, we saw that the college table contains duplicated data. This can be especially problematic. We want to modify the duplicated information because we'll have to make same updates in multiple locations. I mean, it's actually not that difficult. For example, suppose that a faculty member named Professor Hill changes their email address to Hill College Edu and asks you to update their school database accordingly. Since multiple students may have Professor Hill as an advisor, you'll need to update her email address in multiple rows of the table. To do this, your first instinct might be something like, yeah, it's exactly what I would do this. Unfortunately, this would cause problems if there are multiple professors with the same name. I guess that's why you have their last name too. But okay. We accidentally modified two professors' emails when we only intended to change one. If advisor information were housed in a separate table, we could have imposed a unique or primary key constraint on the advisor email column to make sure that no two advisors have the same emails recorded in our database. Also, you probably wouldn't be doing advisor name Hill. You would probably be doing advisor email and his old email. That way you don't get this problem, but okay. Because names are more common than emails. Like encountering the same name is more likely than encountering a same email in a database. But sure, you do you, Codecademy. Okay. Query the college table to print out the advisor name, advisor department, advisor email in that order for all students with Professor Sommer listed as an advisor. Sure. Mm-mm. We have two Sommers. Update Professor Sommer's email to be Sophie at college edu. Make sure to only update the email of Professor Sommer in the statistics department. Not really that complicated. And you just do Sommer 8. And if you do this again, changed properly. Let's again consider the college table. In the last exercise, we saw how data duplication can complicate database modification. Unfortunately, there's another potential problem that can arise when all columns in a table do not depend on the primary key. New data cannot be inserted into the table until a primary key is known. What? Okay. Suppose, for example, that the school hires a new advisor in the computer science department. The advisor's name is Professor Algorithm, and his email algorithm1000 at college edu. Fortunately, we cannot add a new row to this database table because Professor Algorithm has not been assigned to advise any student yet. And we need a primary key. Ah, I see. In order to be inserted into a new row date. Okay. To get around this problem, we could theoretically come up with a fake student ID and leave non-relevant columns empty. I forgot how many random songs I have in this playlist. Like they're good songs, but a lot of them are like songs over videos that are like tribute videos to House MD. So I was really into it back in the day. It's like OST from House as well. Okay. So we're inserting with a fake ID. Bad practice. The problem here is that we had to create a fake student ID in order to put Professor Algorithm into our table. This is bad because we can no longer use a simple count of unique student IDs to accurately determine the number of students who are enrolled. We also have to remember to modify or delete this row in the future when Professor Algorithm starts advising students. Otherwise, we'll open ourselves up to future mistakes and inconsistencies. For example, if we later want to know how many students Professor Algorithm advises, we might accidentally count this fake student as a real person. Some code has been provided for you in script SQL to attempt to insert new row into college table for an advisor with advisor name Stern, blah, 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 blah. As is, this insert will throw an error and not work because we have not included a value in the primary key column. Press the run button to inspect the error message. Run. Sure. Edit the insert statement from the previous step to include a student ID of -1. Sure thing. Like the exercises kind of went easier now. I guess they're just illustrating some points. Below your insert statement, query the table to inspect this new row. You now have a student ID listed in your database that doesn't actually match with the student. This is a problem. Okay. Boom. Search and sort efficiency. Again, consider the college table. Besides the fact that the major related columns are not directly dependent on the primary key, you may also notice that there are two sets of columns where a student's major and related information can be recorded. This structure can make queries related to students' major less efficient and more messy. For example, suppose that your boss is interested in figuring out which majors are the most popular. They ask you to produce a table of unique majors along with the number of students who have declared each one, sorted by popularity. If all information about student majors were contained in a single column, this would be relatively simple. Or the first few rows returned by the query above would look something like yes. Problem is that these counts are incorrect. They completely ignore majors recorded in the majors 2 column. Ah. To remedy this, we'll have to join the major 1 and major 2 columns together somehow, creating additional complexity. Sure. Let's first combine all of the data found in major 1 and major 2 columns. Note that major 2 has many null values because some students only have one major. Fill in the blanks in the provided query. Oh, we're using union? Okay, I guess we can use union. I was thinking about doing a left join, but hmm, Jmore. College where major 2 is not null. Boom, 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 boom. Okay, edit your query from step 1. First, delete the semicolon at the end. Use the syntax indicated below to query the list of majors you produced in step 1 and return each major name alongside the number of students who have declared that major, ordered by popularity from most to least popular. Uh, oh. Okay, so with majors as and we do select. We need what? So this will give us majors. We also need count, basically rows. Turn each major name. Oh, so just major. And count that. Group by majors. Order by count descending. I think this new. Well, it actually gave us what we needed. But Codecademy is not happy. Major. Major. Sure. Now you can queue up order by count directly. You don't have to do that. Okay. So compare your results to the output from narrative, which only looked at major 1. Once we include major 2, is the most popular major still history, or has it changed to something else? History will never be the most popular major, nor will geology or Spanish. I'm assuming the most popular in real life. Chemistry, biology, statistics. Economics is probably up there. Also, huh. Okay, let's actually look this up. Most popular. Oh, sneezing coming. Most popular majors. Business. Like I said, economics. Health. Health is a major. Business. Oh, third place. What's the black one? Is combined? Oh, it's liberal arts and sciences. General studies and humanities. Hmm. Then we have health professions and related programs. Second place. Okay, so business is consistently at the top, then health professions, then social sciences, history, engineering's in fourth place, biological, and biomedical sciences. What's in the last place? Education. Makes sense. All right. Restructuring the advisor columns. Up to this point, we've examined problems with this database design and implications for queries and modifications. In this exercise, we'll start to redesign our database to address some of these problems. First, we saw that every student with the same advisor has identical information recorded in all advisor-related columns in the college table. One way to address this is by moving the four advisor-related columns into their own table with only one row per unique advisor. This helps ensure every table has its own purpose or concern. Makes sense? To create a new table from an existing one, we can precede any query with create table and do new table name as. Oh, and then we query select distinct from college and tell it the columns. We can also delete columns from our original table once we have moved them. For example, the following code drops the columns major 1, major 1 required from the college table. What about major 2? Okay. So let's create a new table advisors. Advisors as select distinct. Oh, advisor email. Advisor name. Advisor department. From college. And then we will also want to alter the table and drop the columns that we have just moved. Hmm? Alter the table, advisor name and department. Why not the email? Okay. Sure. Not lead, blah, 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 blah. Below them, query a new advisor table for all rows where Brunson's listed as the advisor name. Mm. Didn't have it in the didn't have the email. Oh, Brunson. So wait a sec. Does this college only have one advisor? Wait, where was it? No, it has like a bunch of advisors. Note that this information is now condensed to a single row in our database. Why though? Oh, never mind. We're selecting this. Okay. Brain is frying. Select all the advisors. Yeah, there we go. We get all of them. Okay. Restructuring the major columns. We saw in the previous exercises there are two potential issues with the four major related columns in the college table. Yes, there are. The two credits required columns describe the majors themselves rather than the students, creating duplication. The repeating sets of columns make it challenging to search and sort through our data by major. To address these problems, we can extract the four major related columns to create two new tables. Yeah, but then you have to like create join tables, so might as well model your database properly from the get-go. Majors table listing each unique major and the number of credits required. Sure. And a cross-reference table that matches students with majors. Note that we need two additional tables because the relationship is many to many, of course, while each major has only one value. What? Because the relationship between students and majors is many to many. Multiple students can have the same major. Each student can have multiple majors, while each major has only one value of credits required. Okay, after creating these two new tables, student and major data will be stored in three smaller tables that are related as follows. Okay. So we have student ID, major stuff, and student majors stuff. This should be major ID, and this should have the majors table should be like ID, major, and credits required. But okay, whatever. Do, 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 do. Let's take a break. I'm gonna stretch my legs. a little bit because I am dying. C in 10. Wait a second. My Twitch thing is saying that I'm offline. No, I'm not offline. Okay, this is weird. But yeah, Thor is hella tired as well. He's like sleepy. Usually when I come to his bed, he's up for cuddles and playtime. Now he's just like, pet me. I'm sleeping, dude. Okay. Let's move on. Okay, so create a table called majors that contains major 1 and major credits, required columns from the college table. Use the sync keyword to only include one row per unique major. For simplicity, we are assuming correctly that all possible majors are represented in the major 1 column. Okay. So create table majors. Wait, how do you do that again? Oh, as. As select this distinct major 1 and major 1 credits rect from college. Think that's how you do it. Yeah. Okay, and below your first create table statement from step 1, copy paste and fill in the blanks in the following code to create a table called student majors containing all unique student major pairs. Sure. Create table student majors as select major 1 as major. Wait, select major 1 as major and select from majors. Majors have major 1 credits required. Major. Wait. Our student majors just need student ID and major. Oh, so just student ID? From... I'm confused now. Major 1. Oh, we can do college, right? And then union. All select major 2 as major, and also student ID from college where major 2 is not null. Right? Correct. Below the two create table statements from step 1 and step 2, write an alter table statement to delete columns from the original. Okay. Alter table college drop column major 1. Just copy and paste that. Copy and paste that. Nope, don't explain the code. Did not ask you to do that. Technically I did, but it was a mistake. So this. Oh crap. We need 1, 2, 3, 4. 4. Do this. Copy paste magic. That should be fine. Oh, sneezing coming. Ah. Okay. Below all of your create and alter table statements from the previous steps, query the student majors table and print out the first 10 rows ordered by student ID. Okay. Okay, select everything from students majors order by student ID and limit to 10. Okay, looks good. Wait. Oh, no, we got everything. Okay. Probably would have done it the other way around, just have student ID first instead of major, but technically. Oh, yeah. Would have done it the other way around. I guess we can fix it. Just for my sanity's sake. There we go. Creating versus modifying a database schema. In the last few exercises, we used columns in an existing database table with data already inserted to create 3 new tables, then dropped the redundant information from our original table. While this kind of table and schema modification can, and does happen, it is much easier and often preferable to implement the schema design before data has been inserted into a database. Yeah. This is because existing data might already violate constraints and we would like to impose under a new structure. Moving and dropping columns is also not quite enough to turn the single college table from exercise 1 into the 4-table version we likely would have designed if starting with no existing tables or data. For example, the 2 figures below show the original schema with a single college table compared to the normalized version with 4 tables. Sure. Yeah, each student has an ID. Each major has an ID instead of relying on the major. Yeah. previous exercise, we created tables similar to the ones in the four table schema described above. However, there are some important differences. For example, the advisor name column is renamed to name in the advisors table because it is already clear that everything within that table describes advisors. So, yeah, it's much easier to create a schema properly instead of fix one later. College table is renamed students because all non-student related data has now been moved into other tables. Primary keys in the advisor students and major tables are now unique integer values. While it is valid to use advisor email as a primary key in the advisor table, it can make things more difficult when we want to update or delete an email address. In the for table schema, we'll also want to implement some constraints that were not necessarily or not possible in the original version. For example, we can now implement a unique constraint on the email column of the advisors table, ensuring that no two advisors have the same email listed. We can also enforce a foreign key constraint on the advisor's ID column of the students table so that each advisor ID in that table matches an ID in the advisor's table. What are you chewing there? Are you chewing your toy or are you chewing your bed? Huh? You look guilty. Are you chewing the bed? Huh? He looks guilty as hell. What are you doing there, huh? Thor? Thor? Okay, he's ignoring me. Oh no, in this exercise, we'll create the four table version of the schema using create table statements instead of by extracting, deleting, and renaming columns from the original college table. Bah. Honestly, I don't feel like it. I don't feel like doing this anymore today. It's like just ugh. Let's see. Can we do something interesting? Yes, we can, actually. Let's we're that's it. We're done. We're done gaming today. I mean, we're done studying today. Let's close this. What we're going to do is we're going to try out a new game. Let's update our stream information. Sir, excuse me. Surprise. Come on. Allow me to type. Surprise gaming for prize gaming to end the week. Okay, we're not going live again. Balatro. There we go. Let's update our tags as well. I feel like we deserved a little bit of gaming, and considering that we're gonna not do that on Saturday, might as well do it now. Just for the couple of hours or hour and a bit left of the stream. This, what else? Poker. There. Also, we're jumping into intermission until I'm done with all of this. Done. Okay. Now I have to actually buy it and download it. Secrets away. Gonna give all my secrets away. No, shouldn't take long. Actually, it's already done downloading. Okay, let's quiet down the music because we want to actually hear what happens in the game. Right? Right? Yes, we do. Okay, let's take a look. Whoa, whoa, whoa. Being very loud. Come on, find the game. I know you can do it. Guess not. Let's take a look at our options. Settings, video, borderless, windowed full screen, VSync on, apply. Now it should be able to find it. Nope. Come on. Capture it. Full screen, borderless. Oh, it's the wrong thing. Okay, what if we do, instead of game capture, capture specific window, capture this window. No? Ah, there we go. Except it's very weirdly stretched out. Okay. This should be fine. All right. Also, probably could move the camera. I don't know. We'll see where we move it once we start playing. Well, hello there. My name's Jimbo. I'm here to help you learn how to play. I know a little bit of how to play, but I guess I could use a refresher. Your goal is to earn chips to defeat the enemy blind. This here is a small blind, and you only need to score 300 chips to beat it. Select small blind to start the round. Sure. Okay. You earn chips by playing poker hands. Each poker hand earns a base amount of chips multiplied by some mult. We can now make this window smaller, return it back to its position. Instead of having only that displayed, and also want to update this a little bit. Okay. See your poker hands in the run info area, along with other info about your current run. Okay, so we have our hands, what they're worth, what they give us. We also have blinds. We have vouchers. Okay. Cards also earn you some chips. Hover over to see. Ah, okay. Now select up to 5 cards to play and press play hand. All right, let's see what we got. Well, we have pair. We don't have any flushes. And no straights either. Okay, let's play a pair. You can also discard up to 5 selected cards to try and make even stronger hands. Try it. Okay, so we have 5, 6, 7. Okay, let's get rid of these. Careful. You only have a limited number of hands and discards per round. Yeah. Earn 300 chips before you run out of hands to win this round. Good luck. Okay. Let's take a look. Well, we have 2 pair. Could play that. Or we could try for a 3 of a kind. Because a straight is probably unlikely. Also, now that I can see things, I can probably move the camera like up here somewhere. There we go. Okay, so let's get rid of these. Ah, there we go. And now we have ourselves a full house. Cool beans. Cash out $5. Nicely done. Now that you're flush with cash, you can buy some new cards from the shop. Show me. Try buying this handsome devil. 4 plus mult. Sure. This is one of the 150 jokers you can add to your run. Every joker does something different. This one adds +4 mult to every hand you play. That's nice. Be picky. You can only carry 5 joker cards at a time. That was 6 at some point, wasn't it? I watched someone play back like, I don't know, half a year ago. And that was 6, but now it's 5. Okay. They did some nerfing. Now buy the other card from shop. Enhances 2 selected cards to mult cards. This tarot card is a consumable. This one will enhance your playing cards. Hold on to it. Okay. You can carry up to 2 consumable cards with you at a time. If you save up enough, you can buy a voucher. Vouchers passively upgrade your run. Vouchers are restocked after you defeat a boss blind. And check out both of the booster packs in every shop. They're full of goodies. Let's move on to the next round. All right. Selecting the big blind will earn some cash. Or choose to skip it, get a tag. Each tag has a unique effect. But keep an eye on the big boss blind. That's an ability you'll need to plan around. If you beat it, then the ante goes up and all blinds become harder. Beat ante 8 to win. Now choose your path. All right. Okay, so score at least gives $1 per unused discard this run. This. Oh. I'm good. When you get more cards, remember you can rearrange them. Jokers trigger in order from left to right. Oh! And make sure you use your consumables. Select up to 2 cards in your hand and press use on the tarot card to enhance them. What does it do? Enhances 2 select cards to mult cards. Okay, let's take those and then use this. Ah, okay. Okay, what do we have here? Well, let's try to get some full house potential. Didn't happen. Hmm. We're just being unlucky. Okay, let's play this 2 pair. Oh, that was more than enough. Okay. Cashing out. So we have a Sun card and we have a Uranus card. Converts up to 3 selected cards to hearts. And level up 2 pair. Hmm. This could be useful, the voucher. If I want it, I should buy it now. But I also want this one. Alright, let's buy this. Alright, let's go. Well, choose 1 up to 5 tarot cards. Remy the Gay Guy, thank you for the follow. Welcome to the stream. We're finishing off the week with some Balatro. Feeling hella tired. How are you doing, man? Mm, sure, let's open up a pack. See what's inside. You're good? How good are you? Creates a random Joker card. Enhances 1 selected card into a steel card. Converts up to 3 selected cards to spades. Select 2 cards. Convert left card into the right card. What? Regular good? How come only regular good? How come not super fantastic, extra docious, super califragilistically good? Converts up to 3 selected cards to clubs. I think let's just get a random Joker. Ooh, we can get into depth. Yet, not depth. Oh, that means we can actually buy this. Just woke up and you're at work. Oh, I see. And sure, let's open this one. We can get into debt. Celestial Pack, Full House, Straight Flush, 2 pair. Let's continue upgrading our 2 pair. Make it powerful. Powerful. Oh, your boyfriend is at work. Oh, okay. Yeah, the other half being at work is a good enough reason to be regular good. Because it's always better when they're at home. Okay, let's jump into the next round. Discards 2 random cards per hand played. Oof. Have you played Balatro before? Or the better question, I guess, since you came now, I guess you're not here for the programming content because that's what we primarily do during weekdays. But I don't know. I felt really exhausted today from programming stuff and just decided to finish off the stream, whatever like we have left, an hour or so. Yeah, pretty much with some Balatro because I was looking forward to playing it. You played since demo? Nice. I've actually that's how I got the idea to play it. Is I think I saw Northern Lion playing it, and I was like, oh, looks interesting. Might as well try it out. Hmm. Okay, so we're buffing our 2 pairs. So we might want to get rid of 6-5. Hmm. Well, let's get rid of these because I kind of want to aim for jacks. There we go. Would be nice to have a full house. But full house does not equal pair, so playing 2 pairs would probably be better than a full house. Yeah, there we go. 1 turn. Trying to climb out of my debt. $9 will help. Okay. +1 mold per consecutive hand played without a scoring face guard. Ooh. Student debt, yeah. It's only $3, thankfully. Each played card with diamond suit gives plus 0.5, plus 1.5 mold when scored. Suit changes at the end of round. Okay. Okay, we can make this work. Let's get, what is this voucher? Permanently gain 1 discard per round. Let's buy these cards. And we can't buy anything else. So how's your week been? What have you been up to? Or what do you do in general? I guess is the better question. Since you brought up student debt, I assume you're a student? Mm, 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 mm. Okay, let's get rid of these. Ooh, 4 of a kind. Okay, let's play this 4 of a kind. Probably can't play, no. Let's play this 4 of a kind. And that'll give us a buff, which we won't need. Okay, never mind. Lots of money. If played hand contains a straight. I'm not going for straights. Each face card held in hand has a 1 in 2 chance to give $1. We're also not going for face cards. Let's open up some packs. We have a few spare bucks. Ooh. Chips. $3 if this held. If this is held in your hand at the end of the round. Hmm. Sure, let's take that. Let's get the other pack too. Do online classes for nursing? Oh, that's cool. I didn't know you could do that with nursing. I thought you had to be a little bit more hands on. Or is it more like hybrid, where you do theory online and then you still have to come in for some things? Chance to destroy a card. Oh. And then 4 chips with a retrigger. Sure, let's take this. Let's jump into the next round. Liking this. Actually, this might be played without a scoring face card. Played without scoring face card. With a diamond suit. Okay, so we have to keep in mind that we need diamonds and we need no faces. But our pair buff should make up for that. It's a little both. Go in like twice a week. Oh yeah. Okay. Yeah, that makes sense. Not quite. How are you liking nursing so far? And how far along are you into the studies? Put you down. Let's actually reroll these. Ooh, full house. A year in? How many years you got? 4. Okay. Are you liking it so far? What's the vibe? Because usually after roughly a year, half a year in, you get the vibe for the teachers, for the place, for whether you like it or not. Every played card counts in scoring. Press remote when any booster pack is skipped. Is this good? In love with anything medical? That's good. Choose 2 of up to 4 spectral cards to be used immediately. Get the mega spectral. Ah! Okay, let's get it. Okay, destroy 1 random card in your hand. Add 2 random enhanced aces to your hand. Add foil, holographic, or polychrome effect to 1 selected card in your hand. The foil is 50 chips, holographic is 10 molt, and polychrome is 1.5 times molt. Random joker, and destroy all the other jokers. Ooh, convert all cards in hand to a single random rank, -1 hand size. But this is a random joker, yeah. So if it picks like a credit card, then that would be horrible. Destroy one random card in your hand, add 2 random enhanced aces to your hand. Sure, let's use this. We have 5 aces. Okay, and sure, let's use. Wait, we can't use that? Oh, we have to select it. Ace of diamonds. So I guess we want to spread these out a little bit. Let's add it to a 2 since we're incentivized to use non-facial cards. Okay, I don't have any more money. What is this red card? +3 multi when any booster pack is skipped. I would like to get this card though, but I'm out of cash. And I don't really want to sell any of my current jokers. All diamond cards are debuffed. Oh well. Click a card to use it. Which card? 4 threes. Nothing particularly special. You can click and drag the chip in the top left. Top left? Oh, this. What do I do with it? Hello. Stay here. Stay here. No, stay here. Come on. Okay. Ah, this shows how many cards we have left. All right. This shows what kind of hands we've played so far. And our upgrades to our hands. And our vouchers. Okay. Okay, let's get rid of this, and let's keep the ace. Literally no use. Yeah, I figured as much. Do 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 do. Well, we might as well go for a flush. That's unlikely. Okay, that's something. All right, let's play this 2 pair because it's non-faces and it's 2 pairs, which we're kind of buffing. Wait, that's it? Oh, I guess diamonds are debuffed. That's right. Okay, let's play 2 more 2 pair. 1 more 2 pair. Reset this, that's fine. We should be peachy. Boom, 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 boom. Let's rebuild our cash stack a little. Have a spectral pack and a celestial pack. Tarot cards appear twice more frequently in the shop. Each player card permanently gains 4 chips when scored. That's useful. This joker gains 0.5 mult for each card sold. And resets when boss blind is defeated. Spectrals are always crazy. Sure, let's get it. Take a look. There's a chance to get a soul card. What is a soul card? Converts all cards in hand to a single random suit. Add a purple seal to one selected card, which is creates a tarot card when discarded. Okay. Sure, let's add it to the queen. Tarot cards appear. All right, let's save the money. Let's jump into the next round. So we want to keep this. We want to discard this. Probably this. Enhances one selected card into a stone card. 50 chips, no rank or suit. Hmm. Well, we could do this to the 6 here. Because we want to keep it. Wait, did I wipe the thing? Did I wipe its effect? Damn it. I was afraid that might happen, but oh well. Okay. Let's play this full house. Or a 2-pair. I think a 2-pair would be better. Because our 2-pair gives us 60 times 4, while a full house gives us only 40 times 4. Also, we want to start stacking our bus route joker too. Probably get rid of that. So this stone card, I can just play it as part of really any kind of set, any kind of hand. No. How do I use it then? All right, let's discard these. Ooh, a pear. Nice juicy pear. Have fun. Thank you. Um, Cannibalistic Skinwalker Sudoku Mafia Bananas? Excuse me? Is this code for something? Hmm. Alright, let's try to score another pair. Ah. Well, actually, inside joke between me and another streamer. Tell me about it. Now you have to. When this card stays in hand. Okay. Well, you just play one pair, I guess. And let's toss in the stone one for good measure. And Let's toss. Oh, I don't have any discards left. Never mind. Oh yeah, let's just play this pair. It's hard to explain to you how to watch the VOD. Alright, what streamer is it? I might check him out. I think we lost. Maybe. Okay, there's our 2 pair, but it's gonna reset our mult. And now it's hearts too. Because suits change at the end of round, of course. It's not always diamonds. Forgot about that. Okay. This should be fine. Right? Right? Yeah. Knight of Hearts. The banana conversation took place between hour 1 and 2. If you're gonna say between hour 1 and 2, you also have to specify the video, because he probably has a lot of odds. Celestial Jumbo Pack. And Arcana Pack. Every played card counts in scoring. And 40 chips for each remaining discard. Choose one of up to 3 tarot cards. Planet cards. Sure, let's buy this jumbo pack. See what's what. We can further buff our... No, we cannot. We have 4 of a kind. Full house. Straight. Hair. Yes. A full house would be more useful. In his most recent stream, so it's on his banner. All right, I'll take a look. Post stream. So I can share in this secret lingo of yours. Well, we can't really afford anything else, so let's just jump into the blig blind. The bling blind. So... So we have hearts that we want to use. So let's get rid of you and you. We got an Empress. Enhances to selected cards to mult cards. It's exactly how it sounds. Cannibalistic Skinwalker Sudoku Mafia Banana. There's just like no logical relation between any of these words, so it doesn't sound like anything. Uh do we wanna... Right, we want to use 4 and 5s because we have hearts. So we want to get rid of these and probably these. Okay, much better. We have 2 pair. And we can use this on 2 of these. And just play this massive 2 pair. It's the story of Kevin and Big Mike, the bananas. All right. Who are Kevin and Big Mike? Bam, 2000. Okay, let's toss this. This. They're bananas. Okay, of course. Why did I ask? Of course they're bananas. It's so obvious. Do they have last names? Mm, nope. Nope. They're just bananas, Paul. What do you think? What are you talking about? They're just two perfectly normal bananas with names. Okay. Is this what I want to do? Yes. Why would cannibalistic Skinwalker Sudoku Mafia bananas have last names? Yeah, of course. Why? Makes no sense. All right, let's toss in this two pair and we should be fine. Oh, not as fine as I had hoped. Hmm. Three aces. Sure, let's finish off the round. Vape cloud reveal. Oh, sorry. I usually try not to advertise this, but I guess at the camera angle I didn't think about it. It's not a vape, it's an ICOS. Close enough. Yeah, it is. Level up, three of a kind. 1 in 2 chance to create a tarot card when any booster pack is opened. Huh, actually, that's pretty useful. We are buying lots of booster cards, booster packs. Mm, and we will be able to, or should we just buy the Mega Arcana pack? Yeah, let's get the Mega pack. They've been treating me nicely so far. Converts up to 3 selected cards to spades. Enhances 2 selected cards to mult cards, +4 mult. Enhances 1 selected card into a gold card. Okay, steel card. And doubles the money. What is double of -19? Wait, how would this work with the debt thing? Would it just give us a positive? Well, we can select two. So one of them, I'm probably going to use this on. We're stacking hearts this time. Sure, let's go with this. And let's try this one. Nothing. It did nothing. Oh my god. Seriously? Give me minus 30, 38. Okay. Let's go. All hard cards are debuffed. Of course. Of course. Why wouldn't they be? Hmm. Okay, so immediately we want to get rid of basically the entire hand. Well, let's leave the jacks. Let's get rid of these. Because we are stacking pairs, so worst case scenario, we'll at least have a pair. Okay. Okay. still. Okay, let's do this 2 pair first. Then we can try and stack non-face cards after that. Okay, that was decent. Ooh, we have a full house. Sure, let's go with this. We did upgrade it as well. Hmm. 5, 6, 7, 8, 9. That's a straight. And it should work well with our bus multiplier. I need better jokers. Oof. We might get squashed. Okay, that's a pair. All right, let's get rid of all of these. Got a tarot card, and we didn't get what I was hoping. Increase rank of 2, up to 2 selected cards by 1. Uh, we could up the 8. And sure, let's do this 5. It's not going to do much for us, but we can do 2 pair like so, which should give us a decent amount of points. Yeah, there we go. Joker unlocked. Nice. And we got some money. Retrigger all played cards in final hand of round. That seems pretty useful, no? +1 hand size. Level up straights. Let's get this one. And let's do the small blind. Immediately. Very nice. Let's play this. 2 pairs are kind of our 4C right now. It's giving us really nice multipliers. Especially if we stack this bus. We could play the flush, but we're not going to. Instead, we are... Well, we could, but that'll reset our bus thing. Now we have a currently 4 multiplier on that. Okay, let's discard these and hope for... Okay, let's discard these. Get a full, increases rank of up to selected cards by 1. Okay, that's good. Because now we can do this. And this. We could also sell them, but wait, what happened? There we go. Okay, so now we can willy-nilly play these two pairs, which give us the big buku. Wait, that felt like not so much buku. Uh, 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 uh. Okay, let's toss these away. Ooh, yes. All right, let's do two of these. Wait, clubs? Clubs. This is clubs. Instead of this, we'll use this, and we'll toss in the stone card for good measure. Wait, does it not get... Oh, yeah, there we go. Okay, and to finish off, we can look for a 2. No 2s. But another 2 pair that we can capitalize on. Late cards with hard suit give 4 molten scored. Doubles the money. Okay, you do nothing. I already know you. Buffoon pack. Let's take this. We already have... Oh, no space. I guess let's get rid of... Wait, if we get rid of you, we won't be able to buy this anymore. And I'm not very comfortable of getting rid of you just yet. Well, that's a conundrum. Sure, let's sell you and hope that our bus ride card will hold the weight. Okay. So immediately, actually, let's keep this. Toss all of these. Okay, we have one nice pair. Let's toss that in along with this guy. Wait, what about... Oh, okay, never mind. Get rid of you. Stacking diamonds. Let's get rid of you, you, and you. Hmm. Come on, give me a 2. I'm burning through my discards. Okay, well... Wait, this is not gonna trigger this, probably. Sauce you in there as well. Okay, probably lost now. Can't discard you. Sure, let's play this. No, not everything's lost just yet. We probably will have to abandon our bus multiplier. Yeah, and without it, we have no chance. Yeah, I think this is lost. Okay. Just throw these in here. And just a single pair without a scoring face card. So we can throw out face cards, but they just have to not score. And we don't lose. Do aces not count as score as face cards? Interesting. Let's throw this ace in there as well. This is the last hand, but we're probably doomed. Yep. Oh well. I'm literally a fool. What's your excuse? Alright, let's do one more run. Blue deck unlocked. Discover at least 20 items from your collection. Plus one hand every round. And we got a new Joker as well. Joker's Terror Planet. Special cards may appear multiple times. Nice. We have a lot of decks. And we have a lot of difficulties. Let's try the blue one. Shop has an uncommon Joker. No. Let's do it. Let's get rid of these guys. Ooh. Okay, two pair. Good enough. Get rid of you. In the hopes of, yeah, maybe a full house. There we go. Cash out. Plus 100 chips and minus chips for every hand played. Or we get into debt again. Celestial packs always contain the planet card for your most played poker hand. Do we want to go into debt again? It was kind of a trap last time. Couldn't get rid of it. I guess let's try out new cards. Let's get this Joker. Let's go into the next round. Okay, let's try for a full house potential. Nothing. What? Okay. Uh, and that's a full house. Ooh, this is actually nice because it gives a boost to our ship count, which then it's like playing several extra cards. That's very nice. Okay, four of a kind. Enhances one selected card into a gold card. Or we could buy an Arcana pack. Celestia packs always contain a plant card for both played. Sure, let's. You know what? Let's redeem this voucher. Let's redeem this. And then we're gonna go hard on Celestial packs. Must play 5 cards. Wait, must play 5 cards? Ooh. Okay. Well, let's get rid of you, you, and you. Eh. Not exactly what I wanted. Try again. Ooh, there we go. Okay. Let's do this 2 pair. And this. And let's do this 9. There we go. Now let's get rid of you and you. So we could try for a full house. And we're out of discards. Okay, let's just play this 2 pair again. What? Oh, I didn't play five cards. God damn it. Okay, let's try again. I forgot this is a boss. We should be fine. Almost. So 7, 8. Sure, let's play this. Just a lowly pair, but it should be enough. This card will pay dividends in the future. Wait, oh, it melts and then it disappears. Okay. +2 chips for every dollar you have. Yeah, I'm not planning on keeping dollars. Buy this booster pack. We create 2 copies of one selected card in your hand. Or add a purple seal. Creates a tarot card when discarded. Let's create 2 copies. Have a bunch of aces. And we could also buy this. Choose one. When blind is selected, create 2 common jokers. Or 100 chips if played. Played hand contains a 3 of a kind. We're not getting three of a kinds that often, but I guess we're not going for them that often. Actually, let's get this. So, diamonds and hearts. Okay, so let's get rid of you. Ooh, let's play this and let's play this. This should pretty much win us the round by itself. Yep. More than doubly so. Okay, earn $3 for each discarded 2 rank. Oh, rank changes every round. I see. And enhances 2 selected cards to bonus cards, which give us 30 extra chips. Hierophant. Okay, let's get this. And also let's open a booster pack. So we have Uranus, we have Mercury, and Venus. 2 pair. Guess let's get a pair. Upgrade. And let's jump into the next round. Initial cards and booster packs in the next shop are free. Ooh. Actually, let's skip this. Play only one hand type this round. +1 molt per tarot card used this turn. So, if we're going to use only one hand type, we might as well use pairs. And then play this. Hey, Chicken, welcome back. I decided we finish off the week easy with some gaming. So, okay, that should just win it for us. Because I got, yeah, sounds quite right. Yeah. I don't know, I got extremely exhausted. Englendo mode. What is Englendo mode? Gains $3 of sell value at the end of the round. Or convert up to 3 selected cards to clubs. Might actually save up for this voucher, but it's gonna be gone. My game only works in Englendo mode. Your game? What game? The one you created or some game that you're playing? Oh, it's free. It's free. It's free. Everything is free. That's right. I forgot. What game are you playing? So, could potentially sell these bad boys. Buy this voucher. Soul Workers. Oh, I heard of it. It's like a anime type thing. MMORPG. Filling the void WoW left. Yep. I've been trying to fill that void for years now. Unsuccessfully, I might add. Let's buy this. Let's sell it immediately. Sure, let's buy this. Let's also sell it. And let's open these 2 card packs. How long you played WoW for? Uh, Gold card destroys up to 2 selected cards. Why would I want to do that? Notice up to 3 cards, 2 clubs, 1 in 4 chance to add foil, holographic, or polychrome edition to a random joker. Ooh, 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 ooh. +2 molt, 1 in chance to strike. Let's use this. Nope. Wow. Wow. Don't play long, but played way too much. Ah, I see. I see what you're getting at. Whoa. From Wrath of Lich King to Mid Pandaria. Mid Pandaria is pretty much where I stopped as well. I got on the hype train at Wrath of Lich King, and then I did a bunch of private servers, then dropped it off, then came back, add Pandaria, played it all the way up to Pandaria, and then dropped it again because it was like, I don't know, something was off. Then I came back a bunch of times. I think I came back for I don't even remember the name. Warbands, I think. And then I also came back for the vampire stuff when the vampire stuff was happening. Also don't recall thing. Uh Phase 3 was released yesterday, but Battle.net website is down, so I can't download the launcher. What the hell's a Phase 3? Select cards of spades, creates up to 2 random tarot cards, and okay, let's get this one. There we go. And this one gets buffed by tarot cards. Can be used as any suit, and ooh, that's actually pretty good. All right, let's do next round. Phase 3 Season of Discovery, where you get special spells and quote unquote 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 new raids. Okay. Like phase 1 was level 25 maximum. I don't know. The nonsense that's going on in WoW these days is just like it's not up to my taste buds. It's like so much complexity introduced. Old content is like useless now. You might as well not do it. It's just guess that's live service for you. So 1 card into a wild card. Sure, let's upgrade this guy as any suit. Okay. And let's use this as well. Ooh, 50 chips. That's nice. 1 mil per tarot. Wait. Oh, it upgraded this. Okay, never mind. Well, SOD is basically vanilla, but broken in multiple parts. I think they could have gotten away with just slowing down the expansions and just chilling down and like polishing each expansion. Give me give me I would rather have like an expansion every 5 years as long as it's like polished, top-notch quality stuff, you know? SOD is basically vanilla, but broken into multiple parts. Instead of the classical vanilla where you go from level 1 to 60, SOD is the same, but broken into multiple parts where it's first stop level 25, then 40, then 60, with dungeons changed into raids at level max. It just sounds like exhausting just to read that, let alone play it. Yeah, they're drying the cow as much as they can. They've been drying the cow since I don't even know what Pandaria. Uh, okay, let's discard, discard these boys. Hmm. Okay, there we go. There's our full house. Should be getting some fat multiplier stacks too. That was decent. I remember people going crazy and saying WoW was dead when Wrath of the Lich King got released like 15 years ago. It died more than that, quote unquote, died. I don't get it. Honestly, I don't. Like, at this point, World of Warcraft is in its own league that pretty much cannot be matched. Just because just because of the different like play style that it has crafted over the years. It's like every single MMO, even the ones that claim to be WoW killers, you go into them and it just doesn't feel the same. And if it doesn't feel the same, it's not gonna beat the game. Final Fantasy 14 is competing. I played Final Fantasy 14. It's eh, at least to me. Never touched it. I don't know. I played a little bit, didn't grab me. Maybe maybe because I was playing it like in my I don't know, depression days, where the only reason why I played video games was to get some dopamine. But then I would feel bad about playing video games because I wasn't doing anything else productive. Tarot. Earn $5 if 3 or more face cards are discarded at the same time. Okay, let's get rid of you. Productive in game. No, I mean, I wasn't doing anything else in my day that was productive. I was just gaming, and that's it. And then I felt bad because it felt like wasted time. Mm. Blushes, blushes, blushes. Sure, let's buy this. It's cheap ish. Let's buy this jumbo spectral pack. Destroys 5 random cards in hand, gain $20. Ooh. Converts all cards in hand to a single random suit. Creates a random rare joker. Sets money to 0. Add a red seal to one selected card in your hand. Let's use this. Remember I once had 280 days played in a single year when they released Wrath of Lich King? Holy crap. Each card sold. Resets when boss blind is defeated. That's so bad. I was waking up eating. Oh, that's not good. That's Well, hope you're better now because that just straight up at this point in my life that just sounds like straight up depression. Best year of my life, not gonna lie. If you say so. I'm not judging or anything. I'm just because I can relate, you know? But I would not want to do that at my at like currently. Let's also get rid of wait. Diamond suits are our horsey now. Let's keep you. Let's get rid of you. Hmm. Okay. Can toss in a. Will this work? Or only scoring cards trigger that? Yeah, only scoring cards trigger that. Was also smoking like crazy, so it was out of it 24/7. Mm. Yeah, sounds like depression to be honest. It's where you need like so much dopamine to function properly. Is that the only thing that can feed you at like really feed you? Is just massive amounts of video games and weed. What would you again? Go, well, go do it. I dare you. Check him shows up after 280 days. Well, I did it. Mm, 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 mm. Okay, this run is low-key garbage. A little bit. Like I have individual parts for it, but nothing's working together. Finished WoW, mom. Yeah. Holy crap. Imagine that. When will you die? Probably should sell you by now. Okay, we got some money. Ooh, ride the bus. Could be nice. Sure. Oh, no space. Okay, let's sell the ice cream. Let's buy the bus route. Probably will sell this after the boss fight as well. Extra large blind, 11,000. Holy crap. Holy crap. Also gave my league account to a friend yesterday. He inspected what icons I had on the account, and there's some from 2012. Imagine that. I played League a little bit. As far as I as much as I can remember, I think I enjoyed Heimerdinger the most. But then I kind of didn't want to put in the time investment needed to become much better. A friend was only playing that character. That was pretty much me. I was pretty much playing Heimerdinger because he was so fun. Because you didn't have to put yourself too much in danger. Your turrets would do everything for you. And if you were really like rolling items wise, you could just destroy everybody. It was fun times. Hmm. So we're stacking diamonds this time. Okay. Okay, let's play this. Not good enough. But was it the Newheimer or the old one with auto aim rockets? I think it was the one with auto aim rockets, to be honest. Because it was a while back. It was probably like, I don't even know, 10 years ago. Hmm. Flashback from Vietnam. Come on, give me something. Could do just a flush. We have it upgraded. Oh, that's a nice stack. Could start hunting flushes. Also, I made one class exercise earlier, and not surprisingly, that was harder than expected. It do bees like that sometimes. Okay, let's get rid of you, get rid of you, get rid of ye. Oh, I can't discard anymore. Never mind. Okay, let's play you, play you. Let's see what happens. I think I lost this one. Maybe? Maybe not. Mm, okay, well, we only can play this. I kind of forgot we had the bus guard too. Mm-mm-mm. I guess, and let's get rid of these. Okay, we're good. We're good. Whew. Okay, so matter of fact, let's. But this has like 50 chips for each card sold. This could really work. Okay, let's sell this. And let's actually sell this as well. We're gonna get 2 jokers that we can probably keep selling over and over and over again. Hmm. Sure, let's buy and use this. -1 ante, -1 hand per round. Ugh. And let's get this mega celestial pack. And further upgrade our pairs. Level 4. 4 of a kind, straight, full house. Actually, let's do a straight. Because everything else that we have is not synergized with our pair build. Okay, let's do next round. We get 2 new jokers, plus 2 chips for each remaining card in deck. And earn $5 if poker hand is a high card. We can sell this immediately to get a boost to this one. Okay. Okay, this is a bit more tailored to what I would want. But the hand is terrible. Okay, let's get rid of you, and all of you. Okay, that's a nice full house. Or do we want to do full house? Our pairs are so much nicer. Let's try a pair, see what happens. Gotta speed run these damn exercises. 2 more technically. Good luck. All right, thanks, man. I'll be finishing the stream soon anyway. Thanks for hanging out today. Good luck on your exercises. That gave us 3K? Holy crap. Okay, let's do another 2 pair. Okay, stacking this one is the goal here. Is the game. Plus 2 chips for each remaining card in deck. Actually, let's keep this one too. These are just normal jokers. Ooh, what we could do is we could inflate the price, inflate this. So if we buy and then we sell it, like sure, we're spending a little bit of money, but our current multiplier goes up. And let's also buy this. Choose 1 up to 5 tarot cards. Choose 1 up to 3 tarot cards. Sure, let's buy this jumbo arcana pack. Let's take a look. 1 card in stone card. There's 3. Select 2 cards, convert a left card into the right card. Converts up to 3 cards into spades and converts up to 3 into diamonds. Huh. Let's actually select 2 cards, convert the left card into the right card. Boom. Plus 6 mult. Nice. So we can stack mult on this one by using tarot cards. And we can stack this one by just selling jokers that we get. All right, let's open this one. It's going to give us another tarot card too. Doubles money. Max of 20. I can only use them. Okay. Left card into the right card again. Ah. Well, if I would have to select, I'd probably select this one. Converts the left card into the right card. Wait, how is our deck looking? We have a bunch of aces. Could further stack them. left card into the right card. So gonna convert this card into this card into this card. Ah, that's not very good. What if we do this? Oh, never mind. Still left and right. I don't know. None of these are very good. Sure, I guess let's have another 10 and less sevens, or more sevens, less tens. All right, next round. Should get another joker. Plus 4 chips if played hand has exactly 4 cards. No. We are stacking pairs, so we'll sell you. And wow. 6, 7, 8, 9, 10. Could do. Bam. 9,000. 10,000 actually. Getting more cash. That's good. That allows us to buy more jokers and then sell them. 1 in 2 chance to create a tarot card when a booster pack is opened. Oh. Tumult Perot reroll in the shop. No. Well, we could buy tarot card when any booster pack is opened. Well, tarot cards give us good stuffies. So let's buy this. Let's open a tarot pack. Or a card pack, rather. This will give us a tarot card. Plus 10 chips. 1 in 5 chance for 20 mult. 1 in 15 chance to win $20. Ooh, this is actually pretty good. Plus 6 chips, 1 while this card stays in hand. Actually, let's get this. And then we can also get the other tarot or the card pack. It's held, plus 10 chips, plus 6 chips. Sure, let's get the king. We can now sell this. Enhances 2 selected cards to mult cards. Okay, and we'll use them in the game. Cards played previously this ante are debuffed. Ooh, well that's not good. Okay. So enhance these 2 to mult cards. So sure, let's do jacks. Use this. That gives us plus 8. Converts up to 3 selected cards to diamonds. Do we want to do that? Actually, sure, it doesn't matter. That's plus 9 mult. Okay. Let's try our special jacks. This should be a lot of points. Or chips. Oh, yeah. Oh, boy. 17,000. Again. single hand wins. Lots of money. $10. Ooh, tarot cards. Love it. Plus 1 mult per hand played. Minus 1 mult per discard. Ooh, that's actually pretty good. 1 card slot available in shop. Increases rank up to 2 selected cards. Let's get that, and let's get that. Let's also open us... No, let's sell this. Let's open up this. Ah, crap. I should have... Wait. Oh, we don't have the one that gives us the thing anymore. Okay, never mind. Sure, let's get a jack. Okay, so let's save the money. Converts up to 3 selected cards to diamonds. Let's go next round. 11,000. Should be doable with our multipliers. Plus 10 mult, plus 4 mult. Oh, that's awesome. That's actually awesome. Increase rank up to 2 selected cards by 1. Huh. I am thinking we could do this 5 and this 10. Because the likelihood of us getting jacks is pretty high because we have a few extra ones in our deck. So let's use this. Plus 10 mult. Convert up to 3 selected cards to diamonds. Isn't going to do us any good, but might as well get further up on that mult. Plus 2 chips for each remaining card in deck. Okay. And our just normal ass pairs should be slapping hard. Oh, this resets after a boss blind is defeated. Crap. Okay, so not that good. Well, it's pretty good, I guess. All right, let's just finish this off with another pair. That one's great. A holographic Joker. Okay, 50 chips if played hand contains a pair. That's actually pretty good. Okay, I think you've outlived your usefulness. Let's sell you. Let's buy this to further boost our pairs. Let's buy this mega pack. And let's take a look. Full house. Pairs to level 4. Yeah, let's do that. And also 2 pair flush. Sure, let's get our flushes also up there. And we don't have any more money, so let's just go nuts. So this could be good. That's 11K immediately. We didn't get any of the good stuff from it. Sure, let's play another pair. Because we have mults stacking up the wahoo right now. Like 11,000 for a hand. Incredible. Okay, 15 mult when 0 discards remaining. Create a planet card if played hand contains 2 or more 8s. I mean, I would have to get rid of these guys. And these are pretty good. So instead, let's open up Celestial packs and further boost our thingamabob. Straight flush, flush, 2 pair. Well, if we have no choice, let's boost our 2 pair. Because we do often find ourselves where we have 2 pairs, honestly. Another tarot card enhances one selected card into a glass card. Gives the total sell value of all jokers. Okay, and while this card stays in hand. This could, we could buy this card, but it's such a luck-based thing. We'd get more money. Don't entirely want to destroy cards. Sure, let's get a steel card and put it on this 10. And just jump into the next round. All right, so we're going to get face down cards now. I guess I could just do like something like this and just discard them to get, yeah. Okay, let's do a pair. And let's toss these in as well, just to see what they are. Ooh, 3 of a kind. Not exactly what I wanted, but I guess it'll do. 8K. Not bad. So this will already give us pretty good return. Let's play the king pair. That should win us the game. Because our multipliers are going to go insane. Yeah. Not yet. Now let's do the queens. The blue joker is... I don't know. I guess he's okay. More tarot cards. Do a glass card. That is not tasty. Sure, let's open this mega pack. Playing cards can be purchased from the shop. That's just gonna further dilute the loot thingy. Loot table. Destroy 2 cards. Into a stone card. Converts up to 3 selected cards. To clubs, select 2 cards. Convert a left card into the right card. Convert the left card into the right card. Or enhance one selected into a wild card. Actually, let's use this on this. There we go. And also selected card into a wild card. Sure, let's use this. Club. I guess we can do like so. I don't know. Doesn't matter, I guess. As long as we're stacking that multiplier. 0 money. Let's go. 20k shouldn't be a biggie. So our pair currently gives 70 times 6. A 2 pair will give 40 times 3. So our pairs are not yet up to scratch. Or our 2 pairs are not up to scratch. Sly Joker is boosting our pairs quite a bit. Yeah. Let's discard you. Take a look at what we get. Oh, that's a decent pair. Now let's just finish it with the aces. Cash out. Each time a lucky card successfully triggers. It's a lucky card. Oh, it's those things. Ah. You can stack high cards? Damn. Let's pop ourselves. Let's get ourselves a jumbo pack. Let's take a look. Converts up to 3 to diamonds. Select 2 cards. Convert left to the right. Ooh, we could actually do some shenanigans here. Converts up to 3 cards to spades. Creates a random joker card. Creates up to 2 random tarot cards. The Emperor is actually pretty useful because we're stacking tarot cards. So 15 molt. And gives the total sell value of all current jokers. And enhances 1 card into a glass card. Alright, let's use this. Get some money. Let's also buy this. Stone card. Wheel of Fortune. 1 in 4 chance to add foil holographic or polychrome edition to a random joker. Sure, let's use it. Nope. Damn it. Okay, Let's jump into the next round. Okay, let's use this on this 9, I guess. We have to play it. Sorry. Stop breaking your bed. He looks so sad now. So our pair gives us 70, but actually it gives us 20, right? Pair. No, it actually gives us 70. Holy crap. Okay. So that's plus 50 from the blue joker. Or sly joker. Um... Okay. Actually, yeah, let's just play this. Play the 8s. I don't want to get rid of anything. Okay, let's pop the jacks. The next level, I guess, would be for us to upgrade 2 pair. So our pair is level 5. Our 2 pair is only level 2. Okay, let's crack this one. I was waiting for a 9. Plus 2 mult. Nice. $11K. Okay, this is the time pretty much where I should start worrying about not getting enough chips per hand. Each played card with club suit gives, okay, and plus 3 mult for each joker card. Ooh. So actually, but like actually. Bu- 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 this kind of buffs our pairs. This is not really worth it anymore. Sure, let's sell this. Let's buy this. And let's open this buffoon pack. Played cards, no. Create a tarot card if poker hand contains an ace and a straight. Oh, no, not really. Create a tarot card. Hand is played with $3 or less. Ooh, that would be so good. Because we could spend all our money and then we would be constantly creating tarot cards. Okay, let's take a leap of faith. Sell this. Get this guy. And then skip the rest. And then sure, let's buy this. We have to spend money now. Create up to 2 random planet cards. Convert to 3 hearts. Enhances 2 selected cards to bonus cards. Sure. Let's use it on these 6s. Let's do a reroll. So we have 0 money. Okay. 1 in 7 cards gets drawn face down. Not terrible. So now we will be constantly generating tarot cards. If it works like I think it works. Yep. Beautiful. Let's use this. Okay, didn't work out. But every time we'll be stacking fortune teller bolts. So that's amazing. Play another pair. Or let's actually discard all of these. Okay, okay. Sure, let's go for the 5s. Should give us some good stacks. Another tarot. Amazing. 2 molt cards. Yes, please. Use this on... Sure, these 7s. 21 molt. Okay, let's play these. Worst case scenario, it's going to be a pair. Best case scenario, it's going to be a 2 pair. It's a 2 pair. Okay. Turn 1 card into gold card. Does it work if we... No, use, not sold. Okay. Let's do a 3. Because we're going to use it immediately. Okay, matter of fact, all of these are kind of garbage. Let's discard. Ah, there we go. What I'm talking about. Let's do that. And sort of discard these in the process. Okay. Easy peasy. Choosing this Joker was a good idea. Now we just have to spend enough money. Ooh. Another holographic Joker. Ba 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 ba. I don't know, dog. We could replace it. Because this also boosts our hairs. So, like, it could be amazing. +4 molt and +10 molt. Could sell this and buy this and not really lose that much. This gives us 15. This gives us 18. This gives us a good stack of chips to bounce our molts off of. This gives us tarot cards. And this is just stacking molts like crazy. Okay. Let's sell this and let's buy this. It's an upgrade. It allows us to spend our money and level up 3 of a kinds. No. If hand displayed with $3 or less. Yeah, we have $3. Okay. Ante 7. Let's go. Right off the bat, a very nice king pair. I guess building on pairs is the easiest thing to do. Oh, wait. Use this. Or we do that. And now we play it. Now it should go even harder. I'm expecting this to be like 15,000. And 13. Okay. Creates up to 2 random tarot cards. Sure, let's use it. Enhances 2 cards to molt. Sure, let's discard all of that. Oh, use that. Enhances 1 card into a gold card. We don't really need this, but I guess we can use... We really can't take money right now. Because we have $3. And if we have more, it's going to stop giving us tarot cards. So let's use that here and discard these 2. Okay, that works. Okay, let's go crazy. Creates up to 2 random tarot cards. Yes, please. We have strength. Rank of up to 2 selected cards by 1. And doubles my money. No thank you, actually. So let's upgrade these. And let's play the aces. And we're Gucci. Okay, played cards with odd rank give 30 chips. Eh, eh. And let's actually just sell these. Well, no, let's use this one. We get 20 gold. Let's buy this voucher. And let's buy these packs to blow our money away. Steel card. Sure, let's get this steel card. And further up our... Can we further level up our 2 pair? Yeah, we can. Okay. That is beautiful. Next round. Okay. Let's discard all of that. We're looking for big boy cards. Just like that. Ooh, 14,000. Very nice. Converts up to 3 selected cards to clubs. Sure, let's use this on, I guess, these. Doesn't really matter at this point. And okay, let's keep you. Let's discard you. Not a strong enough pair for me. Ooh, these look nice. Sure, let's play them. $16K. Lucky card. Oh. Wait, don't use that yet. Let's get rid of you. Oh, 4 of a kind. How much do we get for a 4 of a kind? 60 times 7. And a pair gives us 85 times 7. So not really worth it. Okay, let's use the magician on this. And then let's just toss in the pairs. We have 3 pairs, which should be enough because we get like 15K per pair, roughly 15K. Yeah, that's beautiful. And we can also upgrade this king too. And play it now, which should give us a lot. And we also can get more money. All right, let's cash out. Let's use this. Bum, 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 bum. Sure, let's get the strength card. Let's also get this pack. Straight. Let's further upgrade our pair. Level 7. Let's get this pack. We're ripe with money. Further upgrade our pair. And let's reroll. Played aces give 20 chips plus 4. Plus 10 multi. No. Let's go. Boss time. -1 hand size. Should be fine. Increases rank of up to 2 selected cards by 1. Yeah, let's upgrade these. And let's play them immediately. Oh, this is so tasty. We need a joker that would multiply our mult. That would be the best. 2 random planet cards. Sure, use. Oh, another pair upgrade. Thank you very much. Another full house. Actually, the first full house upgrade. Okay. Let's toss away some cards. Eh, eh. Okay, let's play this pair. Not the best, but should be also fat stacks of chips. 20k, nice. One selected card into a lucky card. Huh. Let's get rid of you guys. Hopefully, yeah, there we go. That's what I was hoping for, to get another ace, so that we can then hopefully piggyback off of it. Will we trigger it? Maybe? No, we didn't. Oh well. Two molt cards. Sure. Let's use that here. And play these queens. Mmm. These tasty multipliers. 20k per hand hands. Okay. Converts up to 3 selected cards to spades. Yes, please. Use this. Ooh. Holographic. 50 chips. Nice. That is very nice. When blind is selected, gain +3 hands and lose all discards. That could work nicely with the blue joker, but I don't think it's going to work fast enough. Let us buy the spectral pack. We are just going to blow our money, really. All cards in hand to a single random rank. -1 hand size. Create a copy of a random joker. Destroy all other jokers. Converts all cards in hand to a single random rank -1 hand size. No, thank you. I'll skip this one. Let's open this one. Adds the number of times poker hand has been played to mult. Ooh, this could be pretty good because we have played lots of pairs. So our pairs could be further boosted. So adds the number of times poker hand to mult. So +33 mult, essentially. Damn. That's 15 mult. That's chips. That's 38 mult. Well, we could sell this because we're essentially getting 18. This would give us double that. So let's sell that and let's take this one. And let's buy this tarot card and hop into the next round. Last ante. Converts up to 3 selected cards to spades. Sure. And then we're going to get rid of all of these. There we go. That's the big bucks. Oh, yeah, finally in those hundreds. 30k hand. That is amazing. Destroys up to 2 selected cards. Sure, let's get rid of this. 4 pair. It's fine. Have another ace hand. Ooh, this is beautiful. Oh, these sweet, sweet 100 malts. God damn, that's tasty. Uh, plus 20 malt if played hand contains 2 or fewer cards. Ooh, that would be actually pretty good. Played cards with diamond suit. Eh. All right, let's just I guess use this first. Get a world. Converts up to 3 cards. Increases. Okay. Let's buy these packs. I like the fact that you can just blow your money on just indefinitely. Destroy 1 random card in your hands. Add 3 random enhanced faced cards to your hand. Or destroy 5 random cards and gain 20 bucks. Sure, let's use this. Okay, blew the king. Ooh, nice. Face cards, face cards, and we're out of money. Sure, let's go into the next round. 75k. Sure, we can use it on this. Increases rank of up to 2 selected cards by 1. Let's use these. Get our king pair. And let's play these aces. $30k. Sure. Let's use that. You know, I don't have to do it on 3 cards, but let's play these kingos. This is an unbeatable combination. In 5 hands, because I'm basically getting 30k per hand. So that's 150k. So we should be easily clearing 100k per 5 hands. Creates the last tarot or planet card used during this run. What? Converts up to 3 selected cards to diamonds. Sure. Oh. Okay. Sure. Let's use just use this. We're gonna probably get rid of this entire hand anyway. Actually, let's keep you two. Get rid of you and you. Oh, these two fat aces with their own malts. Tasty. But then again, at this point, probably doesn't matter. The +4/+4, it's like just +8 when we're already getting like a lot of chips. Gains +3 mult when booster pack is skipped. Okay. Well, we kind of won, to be honest. Let's open up a couple of last packs. Further upgrade our pairs. Level 10. And let's buy this one. One selected card and has you select 2 mult cards. Sure, use that. On... I don't even know. Sure, let's get the 7 and 9. This card alone pretty much gives us a 50 mult. Not to mention the other ones. All right, let's jump into enhances one selected card and a stone card. Okay, let's jump into the next round. Flips and shuffles all Joker cards. No. Wait, what do you mean flips and shuffles? But I still have my Jokers, right? Because if I don't, I'm screwed. Yeah, okay. It's fine. Oh, this should be a huge stack. Should be like 20k. Easy. 40k. Okay, let's do that. Do that again. Oh, these tasty multipliers. Mmm. So tasty. And these tarot cards are just mmm. Yeah, we could get like 300k easily. Looks like you weren't bluffing. Yep. Awesome. Very nice game. I like this game a lot. 2 times rerolled, cards purchased, cards discarded, cards played. Best hand, 45,000. We played pair 41 times. We could go into endless mode. Or actually, I kind of have to go. So we'll finish this off either on Sunday or I will do it by myself off camera if I won't be able to wait